Imagine a world where we could travel faster than light. This idea, rooted in science fiction yet bolstered by theoretical physics, opens up a universe of possibilities. What if we could explore distant galaxies in mere moments instead of the centuries it currently takes? This could enable us to observe celestial phenomena up close, such as the majestic birth of stars or the eerie dance of black holes, which are often hidden from our view. The concept challenges our understanding of space and time, suggesting that we could bend the very fabric of the universe to our will. If we could travel at light speed, we might encounter alien civilizations. This raises fascinating questions about communication. How would we interact with beings that have evolved in entirely different environments, perhaps on planets with conditions we cannot even imagine? Would they have languages and cultures that we could comprehend, or would they be so alien that understanding them would be impossible? As we think about these potential encounters, we also wonder about the technology required to achieve such speeds. Current theory suggests concepts like wormholes or warp drives, which could allow us to slip through dimensions. Consider the implications for space exploration. We could visit exoplanets orbiting distant stars, potentially finding life forms that vary drastically from Earth's creatures. Imagine standing on a planet where the sky is a different color, or where the wildlife has evolved to survive in extreme conditions, such as intense radiation or low gravity. Each new world could reveal entirely new ecosystems, where the food chain operates under rules we have yet to discover. Additionally, think about the impact on our understanding of physics. Traveling faster than light might require us to rethink fundamental concepts like causality, the relationship between cause and effect. If we can move through space in ways currently deemed impossible, would that open doors to new scientific discoveries? Perhaps we could uncover new materials or energies that exist only in the far reaches of the cosmos, fundamentally changing technology as we know it. Moreover, what would happen to our perception of time? If we were to travel across vast distances in the blink of an eye, would we age differently compared to those we left behind? This notion leads us to consider the potential for time travel, where the past and future could become as accessible as the present. Envision the social and political ramifications of such advancements. Nations would compete for control over faster-than-light technology, leading to new alliances and conflicts. The way we view our place in the universe might shift dramatically as we recognize that we are not. Exploring the universe and the idea of faster-than-light travel captures the imagination, yet it is grounded in the fundamental principles of physics that shape our understanding of the cosmos. One of the foundational theories is Einstein's theory of relativity, which introduces the concept that the speed of light in a vacuum is the ultimate speed limit for any object with mass. This principle arises from the way spacetime is structured. As an object approaches the speed of light, its mass effectively becomes infinite, requiring infinite energy to accelerate further. This means that no matter how advanced our technology becomes, we cannot surpass this cosmic speed limit. Additionally, the fabric of spacetime itself plays a crucial role. According to general relativity, massive objects like stars and planets warp spacetime around them. This warping can create gravitational fields that affect how objects move. If we were to somehow travel faster than light, we would encounter paradoxes, such as the violation of causality, where an effect could occur before its cause. This raises questions about the nature of time and reality, making faster-than-light travel not just a technical challenge but a profound philosophical one. Moreover, the idea of wormholes, hypothetical passages through space-time that could connect distant points in the universe, sounds promising. However, these structures require exotic matter with negative energy density to remain stable, which has yet to be discovered. The search for this exotic matter adds another layer of complexity, as it remains purely theoretical at this stage. Quantum mechanics also introduces intriguing concepts, such as quantum entanglement, where particles become linked in a way that allows instantaneous communication over vast distances. However, this phenomenon does not allow for faster-than-light travel in the traditional sense. Instead, it challenges our understanding of information transfer and locality. The principles of quantum mechanics and relativity are not yet reconciled in a unified theory, which complicates our pursuit of faster-than-light travel even further. In summary, the limitations imposed by the speed of light, the structure of space-time, the challenges of creating and maintaining wormholes, and the unresolved tensions between quantum mechanics and relativity all contribute to the current understanding that faster-than-light travel is not feasible with our existing knowledge of physics. Each of these elements invites us to ponder the mysteries of the universe and the fundamental laws that govern it, highlighting both the boundaries of our understanding and the possibilities that remain to be explored. Early scientists, including Albert Einstein, began to explore the nature of light and its speed in the early 20th century, leading to groundbreaking ideas that reshaped our understanding of physics. Before Einstein, many physicists believed in a fixed medium through which light traveled, known as the luminiferous ether. This concept suggested that light waves needed a medium, similar to how sound waves travel through air. However, experiments, such as the famous Michelson-Morley experiment, failed to detect this ether, leading to confusion and debate among scientists. Einstein's revolutionary theory of relativity, introduced in his 1905 paper on special relativity, proposed that the speed of light in a vacuum is constant, regardless of the observer's motion. This idea was radical because it suggested that no matter how fast someone was moving, they would always measure the speed of light to be approximately 299,792 kilometers per second. This constancy of light speed became a cornerstone of modern physics, challenging previous notions of absolute time and space. As Einstein delved deeper into the implications of his theory, he recognized that as objects approach the speed of light, their mass effectively increases, and time begins to slow down relative to an outside observer. This means that reaching or exceeding the speed of light would not only require infinite energy, but also lead to scenarios where time could behave in strange and counterintuitive ways. His ideas led to the conclusion that the speed of light serves as a universal speed limit for all matter and information in the universe. Consequently, Einstein's conceptualization of light speed limitations significantly impacted how scientists view the fabric of spacetime. The understanding that light speed is an ultimate barrier has influenced numerous fields, from astrophysics, where it helps explain the expansion of the universe, to quantum mechanics, where it raises questions about the nature of reality. The exploration of light speed has not only enhanced our understanding of the universe, but has also inspired ongoing research into the mysteries of the cosmos, pushing the boundaries of what we know and challenging us to think beyond our conventional understanding of time and distance. Exploring the concept of faster-than-light travel leads us into fascinating territory, particularly when considering its implications for Einstein's theory of relativity, which has long been a cornerstone of modern physics. According to this theory, as objects move closer to the speed of light, their mass effectively increases, requiring an infinite amount of energy to reach light speed. This presents a fundamental barrier that has stymied our understanding of the universe for decades. However, if we were to discover a way to travel faster than light, it would challenge the very foundations of relativity, prompting scientists to rethink how we understand space and time. One potential implication of faster-than-light travel is the concept of causality. In simple terms, causality refers to the relationship between cause and effect. If something can travel faster than light, it could theoretically allow information or matter to arrive before it departs, creating paradoxes that could confound our understanding of events. For instance, imagine a scenario where a message is sent to a distant star system and arrives before it was even sent. This scenario raises questions about the nature of time itself, making us ponder whether the linear progression of time is an illusion. Additionally, faster-than-light travel could lead to the possibility of time travel. If we could bend the rules of relativity, we might be able to navigate through time as easily as we navigate through space. This notion has captivated the imagination of writers and scientists alike, but it comes with its own set of complications, including the potential for creating alternate timelines or even meeting past versions of ourselves. Such ideas, while intriguing, challenge our current understanding of the universe and could lead to significant philosophical debates about fate, free will, and the nature of reality. Moreover, if faster-than-light travel were possible, it could revolutionize our exploration of the cosmos. The vast distances between stars and galaxies would shrink, making interstellar travel feasible. This would open up new avenues for discovering extraterrestrial life and understanding the fundamental workings of our universe. We could visit other star systems in a human lifetime rather than waiting for generations. This potential for exploration might lead to technological advancements that we can hardly imagine today, possibly even allowing for communication with distant civilizations or the colonization of other planets. The implications of faster-than-light travel would not only be scientific but also societal. As humanity grapples with the ethical and philosophical questions that arise from such advancements, we would need to consider how to govern our newfound abilities. Would we have the right to explore? Traveling faster than light has long been a topic of fascination in both science fiction and theoretical physics. If such a phenomenon were possible, it would fundamentally alter our understanding of space-time, which is the fabric of the universe as described by Einstein's theory of relativity. Currently, we understand space-time as a four-dimensional continuum where time is intertwined with the three dimensions of space. According to this theory, the speed of light is the ultimate speed limit in the universe, meaning nothing can travel faster than light in a vacuum. However, if we could exceed this speed limit, it would imply that we could move through time as well as space in ways we cannot currently comprehend. One of the most intriguing consequences of faster-than-light travel would be the idea of causality, which is the principle that cause precedes effect. If something could travel faster than light, it might be able to arrive at its destination before it even left. This could lead to paradoxes where an effect happens before its cause, creating scenarios that challenge our conventional understanding of time. These paradoxes have led to many discussions about the possibility of time travel, raising questions about whether we could visit the past or influence events that have already occurred. Additionally, our perception of distances in the universe would shift dramatically. Right now, space is vast and the distances between stars and galaxies are measured in light years, which is the distance light travels in a year. If we could travel faster than light, we could potentially explore distant galaxies within our lifetime, making the universe feel much smaller and more accessible. This would not only enhance our ability to study celestial bodies, but could also lead to the discovery of life beyond Earth, reshaping our understanding of our place in the universe. The scientific implications of faster-than-light travel extend into the realm of quantum physics as well. Concepts like wormholes, which are theoretical passages through spacetime that could create shortcuts between 2 points in the universe, might become more relevant. If faster-than-light travel were achievable, the existence of these wormholes could allow for instantaneous travel across vast distances, revolutionizing transportation and communication. Moreover, exploring the effects of traveling faster than light could lead to new technologies and innovations that we cannot yet envision. As we probe deeper into the mysteries of the universe, the exploration of faster-than-light travel could bring about advancements in our technology and understanding of physics, potentially unlocking secrets of dark matter and energy, which currently remain elusive. In essence, if we were to discover in the realm of theoretical physics and science fiction, the idea of faster-than-light travel has captivated the imagination of many. One of the most discussed concepts is the warp drive, a speculative technology that could allow spacecraft to travel faster than light by bending or warping space around them. This concept was popularized by the Star Trek franchise, where spaceships could move vast distances in the blink of an eye. The basic idea behind a warp drive involves creating a bubble of space-time that moves the ship through space, rather than moving the ship itself at superluminal speeds. This bubble would compress space in front of the ship and expand it behind, theoretically allowing for faster-than-light travel without violating the laws of physics as we understand them. Another intriguing idea is the concept of wormholes, which are theoretical passages through space-time that could create shortcuts between distant points in the universe. Wormholes emerge from the equations of general relativity, suggesting that if they exist, they could allow for instant travel across vast distances. However, the stability and practicality of such structures remain purely hypothetical, and significant challenges, like keeping a wormhole open, would need to be overcome. Some scientists speculate that exotic matter, which has negative energy density, could be used to stabilize a wormhole, but this type of matter has not yet been discovered. Research into these concepts often involves advanced mathematics and physics, exploring the nature of dark energy, quantum mechanics, and the fundamental laws governing the universe. Some researchers are even investigating the possibility of manipulating quantum fields or using advanced technologies to create conditions that might allow for these theoretical travel methods. While we are still far from achieving faster-than-light travel, the exploration of these ideas continues to inspire both scientists and enthusiasts alike, pushing the boundaries of our understanding of the universe. Another theoretical proposal is the Alcubierre drive, named after physicist Miguel Alcubierre, who published a paper in 1994 outlining a method for faster-than-light travel based on the warp drive concept. The Alcubierre drive suggests that a spacecraft could achieve superluminal speeds by contracting space in front of it and expanding space behind it, creating a wave that moves the ship forward. Although the theory is fascinating, it also requires conditions and materials that are currently beyond our technological capabilities. Finally, there are more speculative ideas, such as tachyons, which are hypothetical particles that always move faster than light. If they exist, tachyons could provide a means of communication or travel. The concept of a warp drive is an exciting idea in the realm of science fiction and theoretical physics, primarily because it suggests a way to travel faster than the speed of light. This idea was first proposed by physicist Miguel Alcubierre in 1994. He suggested that instead of moving a spacecraft through space in the traditional sense, a warp drive could manipulate space itself. Imagine a bubble that surrounds a spaceship. This bubble could contract space in front of the ship while expanding space behind it. This means that the ship wouldn't actually be moving through space at superluminal speeds, but rather riding the wave of space itself, allowing it to traverse vast distances quickly. The warp drive concept is rooted in Einstein's theory of relativity, which tells us that nothing can move faster than the speed of light in a vacuum. However, the idea of bending or warping space offers a theoretical workaround. Alcubierre's equation suggested that a spacecraft could achieve this by using a form of energy that is still largely hypothetical, often referred to as negative energy. This type of energy would be required to create the warp bubble and is not currently understood or observed in practical terms. This concept sparked much interest, leading to discussions about its implications for interstellar travel, as it could potentially allow humanity to explore distant stars and galaxies without the limitations imposed by our current understanding of physics. Researchers have since explored various aspects of the idea, considering how a warp drive could be constructed, the energy requirements, and even the effects on time and space. While the warp drive remains a theoretical concept, it has captured the imagination of many, inspiring countless stories in books, movies, and television shows. The notion of traveling to distant worlds in the blink of an eye is a tantalizing one, and while we may not be on the verge of building a warp drive, the exploration of these ideas pushes the boundaries of our understanding of the universe and inspires future generations to dream about the possibilities that lie beyond our current reach. The concept of faster-than-light (FTL) travel has fascinated scientists and science fiction enthusiasts alike for generations. In this theoretical framework, exotic matter and negative energy emerge as key players in making such travel a possibility. Exotic matter refers to hypothetical materials that possess unusual properties, such as negative mass or negative energy density. This is intriguing because, under our current understanding of physics, all known matter has positive mass and energy. However, if exotic matter exists, it could behave in ways that challenge our traditional notions of space and time. One of the most compelling ideas involving exotic matter is the Alcubierre drive, a theoretical spacecraft design proposed by physicist Miguel Alcubierre in 1994. This concept suggests that a spacecraft could achieve FTL travel by contracting space in front of it and expanding space behind it. In this scenario, the spacecraft itself would not be moving faster than light through space. Instead, it would be riding a wave of space-time. For this to work, however, a significant amount of exotic matter would be required to create the necessary warp bubble around the ship. Negative energy plays a crucial role in this process. When dealing with the fabric of space-time, negative energy could theoretically allow for the manipulation of gravitational fields. This manipulation is vital to stabilize the warp bubble and prevent it from collapsing. Essentially, negative energy could counteract the gravitational effects that would otherwise impede the ship's ability to travel through the warped space. Negative energy is often discussed in the context of quantum field theory, where certain quantum states can exhibit properties that effectively lead to negative energy densities under specific conditions. The idea of negative energy isn't merely a theoretical notion, it has some roots in established physics. For example, the Casimir effect demonstrates how two closely spaced plates in a vacuum can experience an attractive force due to negative energy density fluctuations in the vacuum itself. This effect illustrates that negative energy is not just a fantastical concept, but may be a real phenomenon that could potentially be harnessed. Moreover, the implications of exotic matter and negative energy stretch beyond just FTL travel. They invite us to rethink our understanding of gravity, space, and the very structure of the universe. If scientists were to discover or create exotic matter, it could open up new realms of possibilities in physics, potentially leading to advanced technologies that are currently beyond our comprehension. As researchers delve deeper into these fascinating ideas, the exploration of exotic matter and negative energy is not just a quest for faster-than-light travel, it is an faster-than-light travel, a concept often found in science fiction, challenges our traditional understanding of causality and time in fascinating ways. If we consider the implications of moving faster than light, we enter a realm where the rules of physics as we know them may not apply. One of the most intriguing impacts would be on our perception of cause and effect. In our everyday lives, we experience events in a linear fashion. A cause happens and then we see its effect. However, if something were to travel faster than light, it could reach its destination before the initial event is perceived, creating scenarios where the effect occurs before its cause. This could lead to paradoxes like the famous grandfather paradox, where a time traveler might prevent their own existence by altering past events. Furthermore, our understanding of time itself could undergo a radical transformation. Time, as we experience it, is closely tied to the speed of light. It flows in a consistent manner that we can measure and understand. With faster-than-light travel, the flow of time could become nonlinear, allowing for possibilities like time loops or even time travel. Imagine a scenario where one could visit the past or the future, raising questions about free will and destiny. This could lead to a universe where different timelines coexist, each influenced by the choices made in others, resulting in a complex web of realities that challenge the conventional view of a single timeline. Additionally, the implications for communication and information transfer would be profound. If signals could travel faster than light, it could enable instant communication across vast distances. This raises questions about the nature of information and its relationship to time. For example, if you could send a message back in time, would the recipient receive it before the message was sent? Such concepts can be difficult to grasp as they defy our intuitive understanding of how events unfold in a sequential manner. Moreover, the prospect of faster-than-light travel could revolutionize our exploration of the universe. Currently, the vast distances between stars and galaxies limit our ability to explore and understand the cosmos. With faster-than-light capabilities, we could reach distant planets and potentially discover alien life, reshaping our place in the universe. This new level of exploration could lead to advancements in science and technology, pushing the boundaries of what we consider possible. As we ponder these possibilities, it becomes clear that faster-than-light travel is not just a topic for science fiction. It invites us to rethink fundamental principles of physics and our understanding of reality. The consequences of faster-than-light travel is a fascinating concept that has captured the imagination of scientists and science fiction enthusiasts alike. If we could somehow travel faster than the speed of light, it might open up the possibility of time travel, leading us into a world where we could visit different moments in time. This idea is rooted in the theory of relativity proposed by Albert Einstein, which suggests that as an object moves closer to the speed of light, time for that object slows down relative to a stationary observer. This means that if you could travel at or beyond the speed of light, you might experience time differently, potentially allowing you to move backward or forward in time. However, the idea of time travel presents several paradoxes that are difficult to resolve. One of the most famous is the grandfather paradox, which raises the question of what happens if you travel back in time and accidentally prevent your grandparents from meeting. If that were to happen, you would never be born, so how could you have traveled back in time in the first place? This creates a logical inconsistency that challenges our understanding of cause and effect. Another paradox is the bootstrap paradox, which occurs when an object or piece of information exists without ever being created. Imagine a time traveler who goes back in time and gives Shakespeare a copy of his own works. If Shakespeare then publishes those works, where did the original idea come from? This creates a loop with no clear origin, which can be perplexing to think about. Moreover, faster-than-light travel could lead to situations where different observers would disagree on the sequence of events. This leads us to the concept of simultaneity, where two events that appear simultaneous to one observer may not be simultaneous to another moving at a different speed. This could complicate our understanding of time even further, as people might have different recollections of when events occurred based on their travel speeds. In addition to these challenges, there are also concerns regarding the physical implications of faster-than-light travel. For example, traveling faster than light might require an immense amount of energy, possibly beyond our current technological capabilities. There are also theories that suggest the existence of tachyons, hypothetical particles that travel faster than light, but these remain purely speculative and have not been observed. As scientists continue to explore the possibilities of faster-than-light travel and its implications for time travel, we are left with many questions and mysteries. The intersections of time, space, and the laws of physics create a complex tapestry that invites both. The concept of faster-than-light (FTL) travel opens up a realm of possibilities that could revolutionize our exploration of the universe, much like how the discovery of new technologies has transformed various fields here on Earth. Imagine if we could traverse the vast distances between stars in a fraction of the time it currently takes. With our present technology, reaching even the nearest star, Proxima Centauri, would take over 4 years, traveling at the speed of light. However, if FTL travel were achievable, this journey could potentially be completed in mere days or even hours, allowing us to visit multiple star systems within a human lifetime. This capability would not only expand our reach into the cosmos, but also significantly impact our scientific research. For instance, we could conduct real-time observations of celestial phenomena, such as supernovae or the formation of new stars, gaining insights into the processes that shape our universe. Furthermore, FTL travel could facilitate the establishment of research outposts on other planets or moons, where scientists could study alien ecosystems, geological formations, and the potential for life beyond Earth. In addition to enhancing our understanding of astrophysics and planetary science, faster-than-light travel might lead to the discovery of new resources. If we were able to explore distant asteroids or comets quickly, we could harvest materials that are rare on Earth, such as precious metals or even water ice, which could support future space missions or settlements. Moreover, the human experience of space travel could be transformed by FTL technology. The possibility of interstellar tourism could ignite public interest in space exploration, leading to greater funding and support for scientific endeavors. Imagine traveling to a distant exoplanet, experiencing its unique environment, and perhaps even encountering alien lifeforms or ecosystems. The sheer thrill of such adventures could inspire a new generation of scientists, engineers, and explorers. However, FTL travel also raises questions about the implications for humanity. Ethical considerations would emerge regarding the potential colonization of other planets, as we would need to navigate the rights of any intelligent life we might encounter. Additionally, the logistics of travel would require new technologies and infrastructures, which could take decades to develop. In summary, the advent of faster-than-light travel could profoundly change how we explore and understand the universe. From expanding our physical reach to enhancing scientific research, to sparking public interest in ethical dilemmas, the possibilities are as vast as the cosmos itself, inviting us to dream and discover like never before. Faster-than-light travel, often referred to as FTL travel, is a concept that has fascinated scientists and science fiction enthusiasts alike. If humanity were to develop the ability to travel faster than light, the implications for our future could be profound. One of the most exciting benefits would be the potential for interstellar exploration. With our current technology, reaching even the nearest star, Proxima Centauri, would take over 4 years at the speed of light, but with FTL travel, this journey could be reduced to mere days or weeks. This opens up the possibility of exploring new planets, searching for extraterrestrial life, and gathering knowledge about the universe beyond our solar system. Additionally, FTL travel could allow humanity to access resources from distant celestial bodies. Asteroids and moons in our solar system, as well as planets in other systems, may hold essential materials like rare minerals or even water, which could be vital for sustaining future human colonies. Establishing colonies on other planets could alleviate some of the pressures we face on Earth, such as overpopulation and resource depletion. Imagine humanity thriving on Mars or in a floating city on one of the moons of Jupiter, using the resources harvested from these places to support life back on Earth. Moreover, FTL travel could foster international collaboration and unity. As nations work together to develop the technology necessary for such travel, they may also strengthen their relationships and share knowledge. This collaboration could lead to advancements in various scientific fields, from engineering to biology, and create a shared sense of purpose among humanity. The idea of exploring the cosmos together could inspire generations, fostering a sense of global citizenship and responsibility. Furthermore, the understanding of physics and technology that would come from developing FTL travel could also lead to significant advancements in other areas. Just as the space race spurred innovations in telecommunications, materials science, and computer technology, the quest for faster-than-light travel could result in breakthroughs that benefit everyday life on Earth. Imagine improved energy sources, faster communication systems, or even advanced medical technologies emerging from the research and development needed for FTL. On a cultural level, the ability to travel between stars could significantly impact art, literature, and philosophy. New narratives and perspectives could emerge as humanity comes into contact with different environments and possibly even alien civilizations. Our understanding of life and existence could expand in ways we can hardly imagine, challenging our beliefs and inspiring new ideas. While the concept of faster-than-light travel remains theoretical, the potential benefits it holds for humanity's future are: faster-than-light travel, often found in science fiction, poses intriguing possibilities for interstellar communication. Imagine a world where spaceships could zip across vast distances in the blink of an eye, allowing messages to be sent and received almost instantly. This would revolutionize how we communicate with distant civilizations, potentially allowing for real-time conversations with alien species. Currently, when we send signals to the nearest star systems, such as Proxima Centauri, the messages take over 4 years to arrive, and even longer for a response to come back. If we could travel faster than light, we could not only send messages quickly but also visit these places, establishing direct contact and fostering relationships with extraterrestrial civilizations. Moreover, faster-than-light travel could lead to the development of advanced communication technologies. For example, we might create devices that utilize this incredible speed to transmit data instantly across galaxies, bypassing the limitations of light-speed communication. The very nature of how we perceive time and distance would change, as we would no longer be bound to wait years for a reply to our inquiries. This shift could lead to a more interconnected universe, where cultures share knowledge and experiences across the cosmos. However, the concept of faster-than-light communication also raises questions about the potential consequences of such technology. If messages could travel instantly, misunderstandings could escalate quickly, or we might face ethical dilemmas regarding the information we share. In essence, while the ability to communicate at superluminal speeds could bring about incredible advancements and opportunities for cooperation, it might also require us to navigate new challenges in diplomacy and information exchange, reshaping our approach to interstellar relationships. As we explore these possibilities, we are reminded of the importance of patience and understanding in our current interactions, whether with fellow humans or hypothetical extraterrestrial beings. The desire to learn and connect with life beyond Earth remains a driving force in our quest for knowledge, inspiring scientists and dreamers alike to ponder what lies beyond the stars. The discovery of a way to travel faster than light raises numerous ethical implications that stretch far beyond the realms of science and technology. First, one must consider the impact on our understanding of the universe. If we can travel faster than light, we would be able to reach distant galaxies and explore regions of space that have remained unreachable, fundamentally altering our perspective on existence and our place in the cosmos. This capability could spark a desire to explore and potentially colonize other planets, leading to questions about our responsibilities to other life forms we might encounter. Would we have the right to invade or exploit these new worlds, or should we approach them with respect and caution, understanding that they may host their own ecosystems and intelligent beings? Moreover, the societal implications of such technology would be profound. Faster-than-light travel could change how we view time and space, leading to philosophical debates about the nature of reality itself. If we could travel vast distances instantaneously, what would that mean for our concept of time? Would we still have a shared experience of time, or would it fragment into individualized perceptions based on our travel capabilities? This could lead to a new form of inequality, where those with access to such technology could experience life differently than those who do not, creating a divide reminiscent of the disparities we see in today's world. Additionally, the potential for conflict arises. Nations might race to control faster-than-light technology, leading to geopolitical tensions reminiscent of the space race. How would we ensure that this technology is used for peaceful exploration rather than military purposes? The temptation to use such advancements for warfare or to exert dominance over other nations could jeopardize global stability. Furthermore, there are environmental concerns to consider. If we begin to exploit other planets or celestial bodies, what impact would that have on those ecosystems? Just as we grapple with the consequences of our actions on Earth, we must contemplate the ethical ramifications of our activities beyond our planet. In the realm of scientific ethics, there is also the matter of the research itself. The pursuit of faster-than-light travel would likely involve significant experimentation, possibly on human subjects. This raises questions about consent, safety, and the moral implications of such experiments. How do we balance the thirst for knowledge with the potential risks to individuals involved in the research? The scientific community would need to establish stringent ethical guidelines to navigate these uncharted waters. In conclusion, the implications of discovering faster-than-light travel are vast and multifaceted, encompassing our understanding of the universe, societal structures, potential conflicts, environmental ethics. Faster-than-light travel, a concept often found in science fiction, could radically transform our understanding of the universe and our place within it. Imagine if we could travel between stars in mere moments instead of years or decades. This ability would not only make distant planets and galaxies accessible, but would also alter our perspective on the vastness of space. Currently, the nearest star system to us, Alpha Centauri, is over 4 light-years away. With conventional spacecraft, reaching it would take generations, leaving humanity confined to our own solar system. However, if we could move at speeds exceeding that of light, we could explore multiple star systems within a single lifetime. This shift would encourage a sense of connectedness with the cosmos, as we would no longer view the universe as an unreachable expanse filled with distant points of light. Instead, it could feel more like a neighborhood, where interstellar travel becomes as routine as flying across countries today. It would spark a new era of exploration, possibly even leading to the discovery of extraterrestrial life or habitable planets. The sheer scale of the universe would still be mind-boggling, yet with the ability to traverse it quickly, our fears of isolation in the universe might diminish. Moreover, this advancement could lead to new scientific understandings about the nature of time and space. If we could bend the rules of physics as we know them, it might challenge our existing theories, pushing scientists to rethink concepts like gravity, time dilation, and the very fabric of reality. As we venture further into the cosmos, we might realize that the universe is not just a collection of celestial bodies, but a dynamic environment filled with opportunities for discovery and understanding. The implications on our culture, philosophy, and even our sense of identity could be profound. Humanity might begin to see itself as an integral part of a larger cosmic community, promoting unity rather than division. The exploration of the universe at such speeds could foster cooperation among nations, as the endeavor would require collaboration on an unprecedented scale. Imagine the possibilities of shared knowledge and technology, where the goal is not just to conquer space, but to understand and appreciate it. In essence, faster-than-light travel could provide us with a new lens through which to view the universe, transforming it from an abstract concept into a tangible realm ready for exploration and interaction. The concept of distance would take on a new meaning as we venture beyond our planet and engage with the stars, ultimately reshaping our collective narrative as inhabitants of this vast. Faster-than-light, FTL travel has captivated the imagination of many science fiction writers, allowing characters to traverse vast distances in space within a short amount of time. One of the most iconic examples is found in Star Trek, where starships like the USS Enterprise utilize warp drive to exceed light speed, enabling them to explore distant galaxies and encounter diverse alien species. Another notable mention is Dune by Frank Herbert, which features the Navigator Guild, whose ability to fold space allows for instantaneous travel between planets, making interstellar commerce and politics possible. In The Hitchhiker's Guide to the Galaxy by Douglas Adams, the concept of improbability drive humorously allows spaceships to travel across the universe by manipulating probability, leading to unexpected and often hilarious outcomes. The Star Wars franchise also plays with FTL concepts through hyperspace travel, where ships enter a separate dimension to move faster than light, facilitating epic space battles and adventures among different planets and systems. Similarly, in the Ringworld series by Larry Niven, advanced technologies enable characters to travel between stars, showcasing the potential of human ingenuity and exploration. The novel, The Forever War, by Joe Haldeman explores the effects of time dilation on soldiers traveling at near light speeds, highlighting the complex relationship between time and space in the context of war and human experience. In Ender's Game, by Orson Scott Card, the use of Ansible technology allows for instantaneous communication across vast distances, changing the dynamics of warfare in the universe. The concept of wormholes, as depicted in Interstellar, presents a theoretical way to create shortcuts through space-time, enabling characters to explore far-off planets quickly and even travel through time. The Three-Body Problem by Lutz Eschine introduces a unique perspective on FTL travel, where characters interact with alien civilizations and grapple with the implications of advanced technologies that challenge our understanding of physics. These examples illustrate how science fiction not only entertains but also provokes thought about the possibilities of advanced technology and its impact on society, culture, and the human experience. The exploration of faster-than-light travel opens doors to thrilling adventures, philosophical questions, and a deeper understanding of our place in the universe. As authors continue to push the boundaries of imagination, the concept of FTL travel remains a fascinating topic that encourages readers to dream about the stars and the mysteries they hold. Throughout history, various cultures and societies have woven fascinating narratives about faster-than-light travel, often reflecting their values, beliefs, and understanding of the universe. In ancient Greek mythology, the story of Hermes, the messenger of the gods, showcases the idea of speed and swiftness. Hermes was known to travel between the mortal and divine realms with incredible speed, often depicted as flying through the air with his winged sandals, suggesting a connection between the gods and the human desire to transcend earthly limits. Similarly, in Hindu mythology, the concept of vimanas, or flying chariots, illustrates an advanced technology that allows gods and celestial beings to travel vast distances in the blink of an eye. These flying machines symbolize the pursuit of knowledge and the ability to bridge the gap between the earthly and the divine. In contrast, many indigenous cultures have their own unique perspectives on travel across vast distances. For instance, the Native American tribes often speak of spirit journeys, where shamans or medicine people enter altered states of consciousness to traverse the spiritual world. This form of travel, while not faster than light in the scientific sense, embodies the idea of transcending physical limitations and connecting with the universe in profound ways. In some African folklore, tales of trickster figures like Anansi the spider often involve clever schemes that defy the laws of nature, including the ability to move between different realms with ease. This reflects a cultural appreciation for wit and ingenuity, suggesting that the mind can also be a vehicle for transcending barriers. In modern times, science fiction has taken these ancient concepts and reimagined them through the lens of technology and space exploration. Authors like Isaac Asimov and Arthur C. Clarke have introduced the idea of warp drives and wormholes, allowing characters to travel across galaxies almost instantaneously. These narratives often reflect contemporary society's hopes and fears about technology and the future of humanity. In Japanese anime and manga, series such as Cowboy Bebop and Space Battleship Yamato feature ships that can jump through space at unimaginable speeds, showcasing a blend of imagination, adventure, and the quest for exploration. The use of faster-than-light travel in these stories serves as a metaphor for breaking free from the constraints of reality and exploring the unknown, resonating with a culture that values innovation and discovery. Across the globe, faster-than-light travel in stories often symbolizes the human desire to overcome limitations, whether they be physical, spiritual, or technological. In Chinese mythology, when engineers set out to design a spacecraft capable of faster-than-light travel, they would encounter a variety of complex challenges that stretch the limits of our current understanding of physics and engineering. One major challenge is the need to understand and manipulate the fabric of spacetime itself. According to Einstein's theory of relativity, as an object approaches the speed of light, its mass effectively becomes infinite, requiring an infinite amount of energy to continue accelerating. This presents a significant hurdle, as our current energy sources are far from being able to provide such immense power. Engineers would have to explore alternative propulsion methods, such as warp drives or wormholes, which are purely theoretical at this point. Additionally, there are concerns about the structural integrity of the spacecraft. At speeds exceeding light, the effects of extreme forces and cosmic radiation could pose serious risks to both the craft and its occupants. Engineers would need to develop materials and designs that can withstand these harsh conditions, possibly requiring breakthroughs in nanotechnology or the creation of entirely new materials that can endure extreme stress. Another critical issue is communication. If a spacecraft were to travel faster than light, it would likely encounter significant delays in communication with Earth. This could create a disconnect between the crew and mission control, making it challenging to receive guidance or updates during their journey. Engineers would need to devise new methods of maintaining contact, perhaps through advanced predictive algorithms or by developing a communication system that can operate independently for long durations. Furthermore, the psychological and physiological effects on astronauts traveling at such unprecedented speeds would need careful consideration. Being in a confined space for extended periods, coupled with the stresses of high-speed travel, could lead to mental fatigue or health issues. Engineers would need to design living quarters that promote well-being, incorporating aspects like artificial gravity, recreational areas, and psychological support systems to help the crew cope with the isolation and challenges of a faster-than-light journey. Finally, there are ethical and safety concerns to address. The implications of traveling at such speeds could affect not only the crew but also the environments they might encounter. If a spacecraft were to pass through regions of space with celestial bodies or debris, the risk of collision could be catastrophic. Engineers would have to develop advanced navigation systems capable of detecting and avoiding obstacles in real time, ensuring the safety of the spacecraft and its inhabitants. In summary, engineers would face a multitude of challenges in designing a spacecraft for faster-than-light travel, ranging from understanding the physics of space-time to addressing the practical needs of crew members, all while. When exploring the idea of faster-than-light journeys, we need to consider the fascinating technologies that would be essential to support human life during such incredible voyages. First, we'd require advanced life support systems that can provide breathable air, clean water, and food for long durations, as traditional methods may not be feasible in the vastness of space. These systems would likely employ recycling technologies, similar to those used on the International Space Station, but enhanced to ensure the efficient processing of waste into usable resources, creating a closed-loop ecosystem for sustenance. In addition to life support, we would need robust shielding technologies to protect against cosmic radiation, which poses a significant threat to human health during extended travels beyond our solar system. Innovations in material science might lead to lightweight yet strong materials that can absorb or deflect harmful radiation, ensuring that passengers remain safe. Furthermore, the psychological aspect of long-duration space travel cannot be ignored. Technologies aimed at enhancing mental well-being, such as virtual reality environments or social interaction systems, could help maintain morale and prevent feelings of isolation during the journey. Energy generation is another crucial factor. Traditional fuel sources would not suffice for the immense energy needed for faster-than-light travel. Instead, breakthroughs in nuclear fusion or even harnessing antimatter might be required to provide the necessary propulsion. This would allow spacecraft to travel at speeds previously thought impossible, but it also means that onboard energy management systems would need to be incredibly advanced to maintain safety and efficiency. Navigation technologies would also play a vital role. Current systems rely on GPS and other terrestrial references, but in deep space, a new approach using star maps, quantum sensors, and artificial intelligence could help navigate the uncharted territories of the universe. This would ensure that the ship remains on course, avoiding potential hazards and optimizing routes for fuel efficiency. Moreover, communication systems would need to evolve significantly. Traditional radio waves would take too long to travel across vast distances, so implementing quantum communication technology could allow for instant communication across light years, keeping crew members connected with Earth and each other. Finally, the design of the spacecraft itself would need to be reimagined. A modular design that allows for easy repairs and upgrades during the journey could be essential, ensuring that unexpected issues can be addressed without jeopardizing the mission. The use of artificial intelligence in managing the ship's systems and assisting the crew could streamline operations, making the journey smoother and safer. In conclusion, the technologies that would be essential for supporting human life during faster-than-light journeys encompass A. The laws of thermodynamics are fundamental principles that describe how energy moves and transforms in the universe. When we talk about faster-than-light travel, we enter a realm of physics that challenges our current understanding of these laws. In classical thermodynamics, the first law states that energy cannot be created or destroyed, only transformed. If we could somehow travel faster than light, we might find that energy behaves differently, potentially creating situations where energy could seem to appear or disappear in ways that break this law. The second law of thermodynamics introduces the concept of entropy, which is a measure of disorder in a system, and states that in an isolated system, entropy will never decrease over time. Faster-than-light travel could lead to bizarre scenarios, such as time travel, where cause and effect become muddled. Imagine traveling to a point in time before you left. This could lead to situations where entropy decreases, contradicting the second law. This paradox could mean that the fabric of our universe as we know it would have to change to accommodate such travel. Furthermore, if we consider how energy is distributed in a system, traveling faster than light might allow for instantaneous communication or transfer of energy across vast distances. This could create a situation where energy is transferred without the usual constraints, leading to questions about how energy conservation applies in these scenarios. The laws that govern energy interactions, like how heat flows from hot to cold, might not hold up in a universe where faster-than-light travel is possible. In theoretical physics, concepts like tachyons are proposed as particles that could travel faster than light. If these particles exist, they would challenge our understanding of mass and energy. According to Einstein's theory of relativity, as an object approaches the speed of light, its mass effectively becomes infinite, requiring infinite energy to move faster. If tachyons exist, they would have imaginary mass and could lead to a rethinking of energy dynamics, perhaps allowing for energy flows that we cannot currently comprehend. In essence, the implications of faster-than-light travel on the laws of thermodynamics open up a world of possibilities that challenge everything we know about energy, time, and the structure of the universe. These ideas stretch our imagination and push the boundaries of scientific understanding, revealing the intricate and often mysterious nature of the cosmos. Faster-than-light travel is a concept that has fascinated scientists and dreamers alike, offering the tantalizing possibility of exploring the farthest reaches of the universe, where black holes reside. If we could travel faster than light, our understanding of black holes could be transformed in several profound ways. First, it might allow us to reach regions of space that are currently beyond our grasp. Black holes, with their immense gravitational pull, are often located in areas that take light years to reach, such as the centers of galaxies. If we could traverse these vast distances quickly, we could study black holes up close, gathering data that is currently impossible to obtain. Such direct observations could help us understand the formation, growth, and behavior of black holes, illuminating their roles in the cosmos. Moreover, faster-than-light travel could enable us to investigate the effects of black holes on nearby stars and gas clouds. By moving rapidly around these cosmic giants, we could observe how matter behaves in the extreme gravitational field surrounding black holes. This might shed light on phenomena like accretion disks, where material spirals into the black hole, and jets of high-energy particles that are ejected at nearly the speed of light. Understanding these processes could enhance our knowledge of not just black holes, but also the fundamental laws of physics that govern the universe. Additionally, if we could travel faster than light, we might be able to explore the theories that suggest black holes could act as portals to other dimensions or even other points in time. These theories, while speculative, open up the possibility of understanding the very fabric of space-time. If we could visit or even observe the event horizon, the boundary beyond which nothing can escape a black hole, our theories on gravity, quantum mechanics, and relativity might undergo significant revisions. The interplay between these fundamental forces could become clearer, helping us to build a more cohesive model of the universe. Furthermore, faster-than-light travel could facilitate collaboration among scientists across the globe. Imagine researchers from various countries traveling to observe a black hole together in real time. They could share their findings instantly, leading to a rapid exchange of ideas and breakthroughs in our understanding of these mysterious entities. This collaborative effort could accelerate discoveries, pushing the boundaries of what we know about the cosmos and enhancing our collective knowledge about the nature of black holes. In a more speculative sense, if faster-than-light travel becomes a reality, it might also challenge our very concepts of space and time. For centuries, black holes have been viewed as isolated regions. Faster-than-light travel, often seen in science fiction, opens up exciting possibilities for colonizing other planets. Imagine a future where humans can travel across vast distances in space in mere moments, reaching distant star systems that are currently light years away. With such technology, the dream of establishing colonies on other planets could become a reality. First, faster-than-light travel would allow us to explore many more planets in a shorter amount of time. Instead of waiting years for a spacecraft to reach a nearby star, we could send missions that arrive within hours or days, enabling us to gather data, assess habitats, and determine which planets might be suitable for human life. Once we've identified potential candidates for colonization, the ability to travel quickly means we could send larger groups of people, along with essential supplies and equipment, to these new worlds. This would help in establishing a stable presence on the planet much faster than current space travel allows. For instance, if we found a planet with Earth-like conditions, we could transport scientists, engineers, and families within a short time frame, allowing for the rapid development of infrastructure, such as shelters, farms, and energy sources. Moreover, faster-than-light travel could facilitate the transportation of resources. If we could harness materials from asteroids or moons within our own solar system, we could quickly transport these resources to new colonies for construction and sustenance. This would lessen the burden on Earth's resources and create a more sustainable approach to colonization. Additionally, with faster-than-light technology, we could maintain communication and support between Earth and its colonies, ensuring that settlers have access to knowledge, assistance, and supplies as needed. This technology would also open the door to interstellar cooperation, allowing multiple nations or even organizations to work together to colonize new worlds. By sharing technology, knowledge, and resources, we could create thriving communities on new planets, promoting cultural exchange and collaboration, which could enrich human civilization as a whole. Furthermore, faster-than-light travel could play a crucial role in addressing potential crises on Earth. If a natural disaster, overpopulation, or resource depletion occurs, having the ability to relocate people to another planet quickly would be invaluable. It could provide a safety net for humanity, allowing us to look beyond our home planet for the future. In conclusion, the concept of faster-than-light travel is not just a fascinating idea, it holds the potential to transform how we explore and inhabit the universe. The possibilities for colonization are vast, and as we continue to dream and explore, imagine a world where traveling to any star system takes merely a few hours. This incredible advancement would not only change our understanding of space, but would also have profound societal implications. Firstly, the opportunity for exploration would ignite a new era of curiosity and adventure. People would no longer feel limited to Earth. Instead, they could visit other planets, moons, and even alien civilizations, fostering a sense of global unity as humanity reaches for the stars. This would lead to an expansion of our cultural perspectives as people bring back knowledge, art, and ideas from distant worlds, enriching our own cultures and traditions. Economically, the ability to travel across the galaxy quickly could open up new markets and resources. Imagine mining asteroids for rare minerals or establishing colonies on habitable exoplanets. This could create new job sectors, leading to a shift in the workforce towards space-related industries. However, it could also raise concerns about the exploitation of these new worlds, possibly leading to conflicts over resources and territory. The need for regulations and agreements between nations and spacefaring entities would become crucial to prevent disputes and ensure that exploration is conducted ethically and sustainably. Socially, the concept of home would evolve. With the ability to reach other star systems in hours, the idea of belonging could shift from a geographical location on Earth to a broader cosmic identity. People might begin identifying as citizens of the universe rather than just citizens of their home countries. This could lead to a more profound sense of interconnectedness among humanity, encouraging collaboration and understanding across cultures. However, it could also cause division, as some might feel threatened by the idea of a shared cosmic community, leading to a rise in nationalism or xenophobia towards extraterrestrial beings. Furthermore, the advancement in travel technology could enhance scientific research. Scientists could easily gather data from other planets, studying their environments, ecosystems, and potential for life. This influx of information would accelerate our understanding of biology and ecology, potentially leading to breakthroughs in how we care for our own planet. However, it also raises ethical questions about our responsibilities when interacting with other ecosystems. The risk of introducing Earth-based species to alien environments, or vice versa, could have devastating effects on both worlds. On a psychological level, the ability to travel to distant star systems could profoundly impact our worldview. People might start to feel smaller in the grand scheme of the universe, leading to greater humility and respect for life on Earth. Alternatively, it could instill a sense of insignificance, causing existential anxiety about humanity's place in. In the realm of space exploration, the idea of faster-than-light (FTL) travel has long captured the imagination of scientists, authors, and space enthusiasts alike. If the concept were ever to transition from science fiction to reality, current space agencies would need to make significant adaptations to their missions and goals. One of the primary challenges would be the development of new technologies that could allow spacecraft to travel at speeds exceeding that of light. This would likely involve extensive research into theoretical physics, particularly in areas such as warp drives or wormholes, which are often discussed in relation to FTL travel. Agencies like NASA, ESA, and others would need to collaborate more closely with universities and private companies to foster innovation and accelerate advancements in propulsion systems that could one day enable such incredible speeds. Moreover, the training of astronauts and support staff would need to evolve dramatically. Current astronaut training focuses on the physical and psychological challenges of long-duration space missions, but FTL travel could introduce entirely new factors, such as time dilation effects and different forms of communication across vast distances. Space agencies might implement new training programs that prepare astronauts for the unique experiences and challenges associated with traveling faster than light. This could include simulations that replicate the conditions of FTL travel, allowing future explorers to familiarize themselves with the sensations and risks involved. Additionally, there would be a need for a reevaluation of mission planning and logistics. Faster-than-light travel could change the way we approach interstellar exploration, allowing for missions to distant stars that were previously thought to be unattainable within a human lifetime. Space agencies would likely need to design a new framework for missions that could potentially reach other star systems in a matter of weeks or months, rather than years or decades. This would also involve rethinking how we establish communication with spacecraft traveling at such speeds, as traditional methods would likely become obsolete. Furthermore, the implications of FTL travel could extend beyond mere exploration. It could lead to the establishment of new colonies on distant planets and moons, fundamentally altering humanity's place in the universe. Space agencies would have to address the ethical and logistical considerations of colonization, including the protection of extraterrestrial ecosystems and the potential impact on any existing life forms. This would require a robust set of guidelines and regulations to ensure that we act responsibly as we expand our presence into the cosmos. As we contemplate the possibility of faster-than-light travel, we also need to consider the effects on international collaboration. Current space endeavors often involve partnerships between nations, and the advent of the quest for faster-than-light travel has sparked a wave of imagination and innovation, leading scientists and researchers to explore new fields that intertwine physics, engineering, and even biology. One intriguing area that might emerge is the study of exotic matter. This type of matter, which could possess negative energy density, is theorized to be essential for creating stable wormholes or warp drives. As researchers delve deeper into the properties and potential sources of exotic matter, they may uncover entirely new branches of physics, focusing on the manipulation of fundamental forces. Another exciting possibility is the field of quantum mechanics, particularly in relation to entanglement and teleportation. As we push the boundaries of what is physically possible, scientists could develop new theories about the nature of information transfer across vast distances. This could lead to advancements not only in communication technologies but also in our understanding of the universe, potentially reshaping our concepts of space and time. Additionally, the implications of faster-than-light travel might inspire advancements in energy generation. Theoretical models could emerge exploring how to harness energy from phenomena associated with warp drives or other mechanisms that would allow for faster-than-light movement. This could lead to breakthroughs in sustainable energy sources, as the technology developed for space travel might find applications in powering our world. Moreover, the pursuit of this technology could lead to new interdisciplinary studies that blend biology and physics. For example, researchers might explore how living organisms could adapt to high-speed travel, examining the effects of space-time distortions on biological systems. This could open up fields focused on bioengineering and the health implications of interstellar travel, paving the way for advancements in medicine and human physiology. The social sciences might also play a role in this new frontier. As humanity considers the ethical implications and societal changes that would arise from the ability to traverse galaxies, fields focusing on the philosophy of space travel and the psychology of long-duration space missions could emerge. Understanding how humans would adapt to life in space, or even how they would interact with potential extraterrestrial life forms, could become crucial areas of study. Finally, the engineering challenges of faster-than-light travel could stimulate growth in new technologies and material science. Researchers might focus on developing materials capable of withstanding the extreme conditions associated with such travel, leading to innovations that could benefit other areas, including construction and manufacturing on Earth. As the pursuit of faster-than-light travel continues to inspire curiosity and ambition, the fields arising from this endeavor could redefine not only our understanding of the universe, but also our place within it. Faster-than-light travel, if it were to become a reality, could dramatically shift the landscape of global politics and power in ways that are hard to fully imagine. First and foremost, the ability to traverse vast distances in the blink of an eye would enable nations to respond to international crises much more quickly, potentially leading to a new era of diplomatic relations. Countries could reinforce their military presence in conflict zones almost instantaneously, which might deter aggression but could also escalate tensions, as nations would be more likely to engage in show-of-force maneuvers. Moreover, the ability to travel between planets or even galaxies could lead to fierce competition for resources. This competition might not just be limited to Earth's resources, but could extend to those found on other celestial bodies, such as asteroids rich in minerals or moons with water supplies. Nations would likely scramble to stake their claims on these new frontiers, leading to territorial disputes that could mirror historical conflicts over land and resources here on Earth. The concept of space colonization could become a reality, with nations seeking to establish settlements on other planets, which would alter the definition of sovereignty and national borders. As countries venture into space, the dynamics of alliances and enmities could also shift. Countries that currently rely on each other for trade and defense might find themselves at odds over space exploration and colonization rights. New alliances could form based on shared interests in space, while traditional alliances might fracture as nations pursue their own interests in the cosmos. Additionally, the emergence of private companies entering the space race could complicate international relations, as they may exert influence that rivals that of nation-states, leading to a new layer of complexity in global governance. Faster-than-light travel could also have profound implications for cultural exchange and interaction. With the ability to visit distant worlds, people could experience diverse cultures and ecosystems firsthand, potentially fostering greater understanding and cooperation among humanity. However, this could also lead to cultural imperialism, where more powerful nations impose their values on those they encounter in the cosmos, raising ethical questions about the rights of extraterrestrial civilizations, if they exist. Furthermore, the implications for global security would be significant. Nations might invest heavily in technology to defend against potential threats from space or to protect their interests in newly colonized areas. This could lead to an arms race not just on Earth, but in orbit and beyond, as countries develop new technologies for defense and offense. The balance of power could shift dramatically, with nations that successfully master faster than light. Traveling faster than light is a fascinating concept that has captured the imagination of scientists and science fiction lovers alike. However, it's important to consider the potential dangers that could arise from such a journey. One of the most significant concerns is the idea of causality, which is the relationship between cause and effect. If you could travel faster than light, you might arrive at a destination before you even left, leading to paradoxes that could disrupt our understanding of time. This could create scenarios where you meet your past self, or worse, alter events in a way that changes history, leading to unpredictable outcomes. Another danger involves the immense energy requirements that would likely accompany faster-than-light travel. Theoretical physics suggests that achieving such speeds might require an incredible amount of energy, possibly more than exists in the entire universe. This presents a logistical issue, as harnessing or generating this energy could lead to catastrophic failures or unintended consequences, including the destruction of the spacecraft or surrounding environments. Additionally, there's the risk of encountering matter in space at high speeds. Space is not empty. It's filled with tiny particles, cosmic dust, and other debris. Traveling at speeds exceeding light could result in collisions with these particles, creating explosive consequences that would be devastating. The force of impact, even with a small grain of sand, would be magnified enormously, resulting in a high probability of catastrophic damage to the spacecraft. Furthermore, the effects of traveling at such high speeds on the human body are still largely unknown. Our bodies are not designed to cope with the immense stresses that would accompany such journeys. The acceleration and deceleration required to reach and maintain these speeds could have severe impacts on health, including potential injury or even death from forces that would be felt during the journey. Lastly, there is the psychological aspect to consider. The vast emptiness of space and the isolation of traveling faster than light could have profound effects on the mental state of travelers. The experience of time dilation, where time moves differently for those traveling at such speeds compared to those left behind, could lead to feelings of alienation or disconnection from the world they once knew. This could result in significant psychological challenges that might not be easily addressed. In summary, while the idea of traveling faster than light is thrilling and opens up numerous possibilities for exploration and discovery, it also brings with it a host of potential dangers that must be carefully considered. From the risk of paradoxes and the challenges of energy requirements to the physical dangers of space and the psychological toll on travelers. Faster than light travel, if it were possible, could revolutionize the economy of space exploration in numerous ways. The fundamental shift in how we approach travel to distant planets and stars would open up a universe of opportunities for trade, tourism, and resource acquisition. Imagine a future where space travel is no longer limited to our solar system, where colonies could be established on exoplanets, and where interstellar commerce becomes a reality. With the ability to traverse vast distances in mere moments, the cost of reaching other celestial bodies would significantly decrease. This would make it feasible for businesses to invest in mining asteroids or harvesting resources from distant planets, creating a new industry that could rival traditional Earthbound economies. Faster-than-light travel could also foster a new era of scientific discovery. Researchers could send teams to explore new worlds, study alien ecosystems, and gather data that was previously unattainable. The knowledge gained from these missions could lead to advancements in technology and medicine, benefiting life on Earth. Furthermore, the potential for tourism in space would likely emerge as a lucrative market. People might travel to see the rings of Saturn up close or witness a supernova firsthand, creating a demand for space hotels and guided tours of the cosmos. The competition between nations and private companies could intensify, as the first to master faster-than-light travel would gain a significant advantage. This could lead to a space race of sorts, where different entities strive to establish a foothold in space, leading to innovations and advancements at an unprecedented pace. The implications for international relations could be profound, as countries may seek to form alliances or agreements to share the newfound wealth and knowledge generated by space exploration. Moreover, the ability to travel faster than light could lead to the establishment of trade routes between Earth and other planets, allowing for the exchange of goods and services on an interstellar scale. This would not only diversify markets but also create new jobs and industries focused on space logistics, manufacturing, and communication. As the economy expands into the stars, the need for skilled workers in various fields related to space travel and exploration would grow, driving educational initiatives and career opportunities. In addition to economic growth, faster-than-light travel could impact our understanding of life beyond Earth. The search for extraterrestrial intelligence might become more feasible, enabling direct contact with alien civilizations. This could lead to an exchange of ideas, culture, and technology that would further enrich our own society. The potential for collaboration with intelligent life forms could reshape our worldview and inspire new ways. Faster-than-light travel, often a staple of science fiction, opens up an exciting world of possibilities, not just for interstellar exploration but also for a new kind of space tourism that could reshape how we experience the universe. Imagine a future where people can hop on a starship and, in a matter of hours, travel to distant stars and planets, places once thought to be unreachable. In this scenario, space tourism would be a thrilling adventure, allowing travelers to witness breathtaking celestial phenomena up close, such as colorful nebulae, swirling galaxies, and perhaps even the majestic rings of Saturn or the icy landscapes of Europa. Travelers could embark on luxurious spacecraft designed with comfort in mind, featuring panoramic windows that offer stunning views of the cosmos. These vessels might be equipped with advanced technology to ensure safety and to provide an immersive experience, complete with virtual reality systems that simulate planetary environments. Imagine walking on the surface of Mars, feeling the reduced gravity, and gazing at the Earth as a distant blue dot in the sky. The potential for educational experiences would also be enormous. Travelers could learn about the planets, stars, and the science behind space travel while enjoying the journey. In addition to individual travelers, whole families or groups could take part in guided tours of the solar system, exploring different planets and moons, each with its unique characteristics and attractions. Space agencies and private companies might collaborate to create themed trips, such as a galactic safari, where tourists could observe the beauty of alien wildlife or participate in research projects that contribute to our understanding of the universe. Moreover, with faster-than-light travel, the concept of space hotels could become a reality. Imagine floating in zero gravity in a luxury hotel orbiting a distant planet, with amenities that include fine dining and entertainment, all while surrounded by the vastness of space. Guests could have the opportunity to participate in activities like spacewalks, asteroid mining simulations, or even observing cosmic events like supernovae from a safe distance. The implications of such advancements could also extend to the economy, with new industries emerging around space tourism. This could lead to job creation in fields ranging from hospitality to aerospace engineering, providing opportunities for people passionate about space and science. However, with such exciting prospects, challenges would also arise, including the need for regulations to ensure safety and sustainability in space travel. Faster-than-light travel could redefine not only our understanding of the universe, but also our place within it, creating a bridge between Earth and the... While the question of faster-than-light travel may seem far removed from the world of animals and wildlife, it invites us to think about how we manage extraordinary advancements. In the natural world, animals often exhibit fascinating adaptations and behaviors that help them thrive in their environments, much like how we might need to adapt our regulations and safety protocols in the face of groundbreaking technologies. For instance, consider the way elephants communicate over vast distances using low-frequency sounds, which can travel miles. This ability to communicate effectively is crucial for maintaining their social structures and ensuring their survival, just as communication would be vital for coordinating efforts in regulating faster-than-light travel. In the animal kingdom, social species often have complex systems to manage their groups, ensuring safety and resource sharing. A similar approach could be applied to managing technologies like faster-than-light travel. It would be essential to establish clear guidelines, much like how wolves establish territories to prevent conflicts. These guidelines could involve creating designated routes or zones for travel, thereby minimizing the risk of accidents or unregulated travel. Moreover, just as some animals, like bees, work together in a hive to ensure the safety and efficiency of their colony, humans could develop an international regulatory body to oversee faster-than-light travel. This organization could be responsible for setting safety standards, conducting regular inspections, and ensuring that all travel adheres to established protocols. The idea of collaboration is echoed in nature, where different species often rely on one another for survival, such as the mutualistic relationship between clownfish and sea anemones. Additionally, considering the environmental impact is crucial, much like how conservationists monitor the health of ecosystems to protect endangered species. Regulations could ensure that faster-than-light travel does not disrupt the delicate balance of our planet or other celestial bodies. Implementing strict environmental assessments and encouraging sustainable practices would be vital. Just as migratory birds follow specific routes to ensure their survival and avoid dangers, establishing safe pathways for faster-than-light travel could help protect both travelers and the environments they traverse. Furthermore, animals often display warning signals to alert others of danger. In a world with faster-than-light travel, implementing advanced monitoring systems could serve a similar purpose. These systems could track all travel in real time, providing alerts about potential hazards or unauthorized trips. By learning from the natural world, where vigilance and communication are key to survival, we could create a robust framework for safety in this new frontier. In summary, while the concept of faster-than-light travel might seem abstract and distant, the principles of artificial intelligence, AI, could play a crucial role in managing faster-than-light spacecraft, offering solutions to challenges that arise with such advanced technology. Firstly, AI can assist in navigation and route planning, calculating the most efficient paths through space to minimize travel time and avoid cosmic obstacles. Given the vastness of space and the unpredictable nature of celestial events, AI systems could analyze data from sensors and telescopes to predict potential hazards, adjusting trajectories in real time to ensure the safety of the spacecraft and its crew. Moreover, AI could enhance communication systems, enabling instantaneous data transfer across vast distances, which is particularly important when traveling at speeds that exceed light. This would allow for real-time monitoring and decision-making, keeping crew members informed and connected to mission control, even across light years. AI could also manage the spacecraft's life support systems, ensuring that all vital conditions, such as oxygen levels and temperature, remain optimal for the crew's health and comfort during long-duration missions. In addition, AI could be used to analyze scientific data collected during the journey, identifying interesting phenomena or anomalies that merit further investigation. This capability could facilitate groundbreaking discoveries, as AI can process vast amounts of information far more rapidly than a human could. Furthermore, in the event of emergencies, AI could implement protocols for crisis management, assessing situations and providing guidance to the crew to navigate challenges effectively. Another fascinating aspect is the potential for AI to evolve and learn from each mission, improving its algorithms and strategies based on past experiences. This adaptability could be vital in the unpredictable environment of deep space travel, where unforeseen situations may arise. Lastly, AI could also assist in the design and construction of faster-than-light spacecraft, optimizing materials and engineering processes for maximum efficiency and safety, ensuring that the technology keeps pace with the ambitious goals of interstellar exploration. Imagine a world where we can travel faster than light, opening up the universe like a book waiting to be read. If we could zip across the cosmos in the blink of an eye, communication with distant civilizations would transform dramatically. Instead of sending signals that take years or even centuries to reach their destinations, we could engage in real-time conversations with extraterrestrial beings. This instant communication could lead to a shared exchange of knowledge, culture, and technology. If we were to encounter intelligent life on a distant planet, the ability to communicate swiftly would allow us to learn about their ways of life, their history, and their understanding of the universe almost immediately. Picture the excitement of discussing art, science, and philosophy with beings from other worlds, where ideas flow freely and creativity knows no bounds. The conversations could lead to collaborative efforts in solving universal challenges, like climate change or energy sustainability, benefiting all civilizations involved. Moreover, the social dynamics of these interactions would likely shift. With real-time communication, misunderstandings could be resolved quickly, fostering a more cooperative atmosphere. Instead of waiting years for a reply, we could build relationships and alliances that span galaxies. Imagine sharing our music, stories, and experiences while learning about their perspectives and customs. This exchange could enrich our understanding of life itself, revealing diverse forms of intelligence and ways of being. However, this rapid communication would also come with its own set of challenges. The potential for misinformation or cultural misunderstandings would increase, as messages could be misinterpreted or taken out of context. Establishing a common language might be necessary, but even then, nuances could be lost. Just as we face challenges in global communication today, interstellar conversations could present similar obstacles, emphasizing the importance of empathy and patience in understanding one another. In a universe where faster-than-light travel is possible, the fabric of our relationships with distant civilizations would weave a complex tapestry of interaction, bringing together beings from various corners of the cosmos in ways we can only dream of right now. The implications for science, philosophy, and even art would be profound, as we would not just be observers of the universe but active participants in an incredible cosmic dialogue. Each conversation could unlock new mysteries, inspire innovation, and remind us of our shared quest for knowledge and connection across the stars. The concept of faster-than-light travel technology, while still firmly in the realm of science fiction, raises intriguing environmental considerations that can be examined through the lens of wildlife and the ecosystems we know on Earth. One of the primary concerns is the potential impact of such technology on our planet's delicate balance. If a civilization were to develop the ability to travel faster than light, it could lead to increased exploration and exploitation of other planets, which might cause a shift in how we view our own environment. Imagine a future where human curiosity leads us to harvest resources from other worlds, potentially neglecting the conservation of our own natural habitats. Moreover, the energy requirements for developing faster-than-light travel could be astronomical. This leads to questions about where that energy would come from. Would we harness more fossil fuels, risking pollution and habitat destruction on Earth, or would we develop renewable energy sources that could limit our environmental footprint? The methods of propulsion, if they exist, might also pose risks. For example, if we were to create a technology that alters space-time, the consequences on the surrounding environment could be unpredictable, possibly affecting local ecosystems in ways we can't yet comprehend. There is also the aspect of space debris and the potential for collisions with wildlife on Earth. If the technology to travel faster than light becomes a reality, it might lead to an increase in space missions, which could generate more debris in orbit around our planet. This debris can pose dangers not only to satellites but also to the delicate balance of research and monitoring systems that help us study wildlife from space. Additionally, if we were to colonize other planets, what would happen to the native wildlife there? Would our presence disrupt their ecosystems, leading to extinction or the introduction of invasive species that could wreak havoc on these alien environments? The ethical implications of faster-than-light travel also deserve consideration, particularly regarding our responsibility to protect wildlife. If we gain the ability to traverse the universe, will we prioritize the conservation of life forms on other planets, just as we are learning to do here on Earth? The decisions we make about exploration and colonization could have lasting impacts on ecosystems across the cosmos. Furthermore, the potential for interstellar travel raises questions about the long-term effects of human activity on our own biosphere. Would the knowledge gained from exploring other worlds encourage us to take better care of our own? Or would it lead to a sense of detachment, making us less inclined to prioritize the preservation of the natural world we have right here? As we While the concept of faster-than-light travel is still in the realm of science fiction, it invites fascinating discussions about how human physiology could potentially adapt to such extreme conditions. If humans were to embark on journeys through the cosmos at speeds far surpassing that of light, our bodies might face unprecedented challenges. One of the primary concerns would be the effects of rapid acceleration and deceleration on our organs and tissues. To mitigate these effects, it's conceivable that our bodies could evolve to have stronger connective tissues, enhanced muscle resilience, and more efficient cardiovascular systems to cope with the intense forces involved in such travel. Moreover, the gravitational forces experienced during acceleration could be significant. In response, human bones might adapt by becoming denser and more robust to withstand increased stress. Similarly, our circulatory system could evolve to improve blood flow under high acceleration, possibly leading to changes in heart structure or function. This might include a more efficient pumping mechanism to ensure that blood reaches the brain and other vital organs despite the forces acting on the body. In addition to physical adaptations, there could be changes at the cellular level. For instance, our cells might develop better mechanisms to repair damage caused by the intense conditions of faster-than-light travel, such as exposure to radiation or other cosmic hazards. This could involve more effective DNA repair systems or enhanced antioxidant defenses to protect against oxidative stress. There's also the question of mental adaptability. Long journeys through space could lead to psychological stress, necessitating changes in brain function to maintain mental health during extended periods in isolation. Humans might evolve to have improved coping mechanisms, perhaps with heightened emotional intelligence or better social bonding skills, helping us to deal with the psychological toll of such travel. Furthermore, the environment of a spacecraft moving at such incredible speeds could be vastly different from what we experience on Earth. The need for closed-loop life support systems might lead to physiological adaptations for recycling resources more efficiently. Our bodies could potentially learn to utilize oxygen and nutrients more effectively, minimizing waste and maximizing the use of available resources, which would be crucial for survival during long journeys. Lastly, the implications of traveling near or at the speed of light could expose humans to unique forms of physical stress that we can hardly imagine today. This could lead to evolutionary pressures that shape not only our bodies, but also our genetic makeup over generations, possibly resulting in an entirely new branch of humanity adapted for life in the cosmos. The exploration of these ideas inspires both awe and curiosity as we ponder the limits of human adaptability and the potential for life. When considering long-duration faster-than-light travel, it's fascinating to think about the psychological effects it could have on astronauts. The concept of traveling faster than light is still theoretical, but if it ever becomes a reality, astronauts might face unique mental challenges. First, the isolation of being away from Earth for an extended period can lead to feelings of loneliness and alienation. Even with advanced communication technology, the time lag in messages could make them feel even more disconnected from their families and friends back home. As they journey through the vastness of space, the sheer emptiness might amplify these feelings, leading to anxiety and depression. Moreover, the experience of traveling at such high speeds could cause disorientation. The brain is used to processing information at a certain pace, and a drastic change in speed might confuse astronauts, making it hard for them to adapt. This disorientation could lead to a sense of time distortion, where they might feel like time is stretching or contracting, creating further psychological strain. The absence of natural light and the artificial environment of a spacecraft would also disrupt their circadian rhythms, potentially causing sleep disorders. Lack of quality sleep could worsen their mood, impair their decision-making abilities, and heighten stress levels. Social dynamics among crew members could also become complicated. Confined spaces and limited resources might lead to tension and conflict, especially if personalities clash or if the stress of the journey begins to take its toll. Trust issues could arise, as astronauts might feel the need to compete for resources or seek to establish dominance within the group. As time goes on, they might form in-group and out-group mentalities, leading to feelings of camaraderie with some crew members while alienating others. Furthermore, the psychological impact of witnessing the universe from such a unique perspective could be profound. Astronauts might experience a sense of awe and wonder, which could lead to a shift in their worldview. This phenomenon, often referred to as the overview effect, can alter a person's perception of life on Earth and their place in the universe. While this can be uplifting, it might also bring feelings of insignificance or existential dread, particularly if they contemplate the vastness of space and the potential for isolation from everything familiar. Finally, the anticipation and excitement of embarking on such an extraordinary journey could initially mask any negative feelings, but over time, the reality of the mission might set in, leading to a complex mix of emotions. The thrill of exploration could be tempered by the weight of responsibility as astronauts grapple with the faster-than-light travel, a concept once confined to the realms of science fiction, could profoundly reshape our understanding of the universe and influence various religious and philosophical beliefs about existence. Imagine a world where humanity could traverse the vast cosmic distances in mere moments, opening the door to the exploration of distant galaxies and potentially encountering extraterrestrial life. This newfound ability to reach the farthest corners of the universe would challenge traditional views about the nature of creation, the uniqueness of Earth, and the role of humanity within the cosmos. Many religions, which often hold specific views about the origin of life in the universe, might find their narratives expanded or even questioned. For instance, if we were to discover intelligent life on another planet, it could lead to theological debates about the nature of the divine, the purpose of life, and whether these beings have souls or a connection to a higher power. Philosophically, the implications of faster-than-light travel might prompt a reevaluation of our place in the universe. It could spark new discussions about the nature of existence, the possibility of multiple universes, and what it means to be human in an ever-expanding cosmos. The idea of a multiverse where countless realities coexist might gain traction, leading to new schools of thought that challenge conventional beliefs. Additionally, the very act of traveling faster than light might encourage a more profound sense of interconnectedness among all living beings, fostering a universal perspective that transcends individual cultures and religions. As humanity ventures beyond our solar system, the experience of seeing the universe firsthand could inspire awe and wonder, potentially leading to a resurgence of spiritual beliefs grounded in the grandeur of the cosmos. This shift could also invite a more scientific approach to spirituality, where the mysteries of the universe are explored through both empirical research and philosophical inquiry. The blending of science and spirituality could create a rich tapestry of understanding, where the boundaries between the two become less distinct. Furthermore, faster-than-light travel could lead to societal changes, as humanity begins to think of itself not just as inhabitants of Earth, but as citizens of the universe. This shift in perspective might encourage a more global and cosmic awareness, promoting peace and collaboration across cultural and religious lines. As we explore the stars, we could find common ground with others, whether they be from different parts of Earth or entirely different worlds. In this new era of exploration, the questions we ask about our origins, purpose, and destiny may evolve. As we encounter the unknown, our beliefs and imagine a world where humanity had discovered faster-than-light travel centuries ago. The age of exploration might have taken on a completely different dimension. Instead of sailing ships navigating the oceans, explorers could have zipped through the cosmos, reaching distant planets and moons. This could have led to earlier contact with extraterrestrial civilizations, reshaping our understanding of life beyond Earth. As the Age of Enlightenment unfolded, scientific minds might have collaborated with beings from other worlds, sharing knowledge and technology. The Industrial Revolutions could have been accelerated by alien innovations, leading to a more advanced society much earlier in history. Wars fought over resources could have taken on a new meaning if humanity was able to tap into the vast resources of other planets, potentially preventing conflicts on Earth as nations look to the stars for their needs. The impact on colonization would be profound. Instead of establishing colonies in the New World, explorers could have founded settlements on habitable exoplanets, creating entirely new societies with different cultural influences. This could have changed the course of history for indigenous populations, as Earth's nations sought to expand their empires beyond their home planet, leading to different dynamics of power and trade. Moreover, key historical events like the World Wars might have been influenced by the existence of faster-than-light travel. Countries could have formed alliances not just on Earth but also with extraterrestrial allies, changing the landscape of global politics. The atomic age might have evolved differently if interstellar threats or opportunities prompted nations to cooperate on a cosmic scale rather than focus on earthly conflicts. Imagine the space race of the 20th century turning into a full intergalactic competition, with nations striving to establish their presence on other worlds and secure alliances with alien beings. The development of technology might have advanced rapidly, as the urgency to adapt to interstellar travel pushed human ingenuity to its limits. Humanity's relationship with the universe could have been transformed, viewing the cosmos as not just a vast emptiness but a bustling community filled with diverse life forms and cultures. Philosophies and religions might have evolved differently, as encounters with alien civilizations challenged humanity's understanding of existence and its place in the universe. In this alternate reality, the exploration of space would not just be a dream but a norm, leading to profound changes in society, culture, and our understanding of what it means to be human. Each leap into the stars would bring new challenges and adventures, shaping history in ways we can only imagine. The ramifications of such a leap in technology would ripple. Faster than light, FTL travel is a fascinating concept that could dramatically change our approach to exploring the universe and searching for extraterrestrial life. Currently, our spacecraft can only travel at speeds much less than the speed of light, which limits our ability to reach distant stars and galaxies where alien life might exist. If we could achieve FTL travel, the vast distances that separate us from potentially habitable planets would become much less daunting. Imagine being able to visit a star system that is several light years away in a matter of days or weeks rather than years or even centuries. This would allow scientists and researchers to explore new worlds and conduct research in real time, significantly speeding up our understanding of the universe and its inhabitants. With FTL travel, we could send missions to exoplanets within our own galaxy, such as those in the habitable zone where conditions might be right for life. Currently, we can only observe these planets from afar, gathering data through telescopes and waiting for the results of automated probes that take years to reach their destinations. If we could traverse these distances quickly, we could not only explore these planets for signs of life, such as water or organic compounds, but we could also make contact if intelligent beings are present. This prospect of direct interaction with extraterrestrial civilizations is thrilling and raises many questions about communication and understanding. Moreover, FTL travel could enhance our ability to conduct astrobiological studies. We could investigate moons like Europa or Enceladus, which are believed to have subsurface oceans, and dig deeper into their potential to host microbial life. The ability to travel faster than light could also facilitate the establishment of human colonies on other planets, providing a base for continuous research and exploration. These colonies could serve as hubs for scientists from around the world, pooling resources and knowledge in the quest to find extraterrestrial life. On the other hand, the implications of FTL travel extend beyond just exploration. It would likely lead to a shift in how we think about our place in the universe. The realization that we could reach other civilizations and communicate with them might challenge our understanding of life and intelligence. We might find ourselves pondering complex questions about ethics, coexistence, and the responsibilities that come with such advanced technology. Additionally, FTL travel could encourage international collaboration in space exploration. Countries that have previously operated independently might unite in their efforts to explore the cosmos, sharing knowledge and technology in pursuit of a common goal. This cooperation could mean that the search faster than light travel, often referred to as FTL travel, could revolutionize how we think about space defense strategies in the future. Imagine a scenario where spaceships could travel vast distances across the galaxy in mere moments, rather than the long years it currently takes with conventional propulsion methods. This capability would dramatically change how we respond to potential threats, whether from extraterrestrial entities or rogue actors from within our own solar system. With FTL travel, defensive maneuvers could become incredibly swift, allowing for rapid deployment of forces to protect vital locations or to intercept hostile ships before they could reach their targets. Additionally, the ability to travel faster than light would open up new avenues for reconnaissance and intelligence gathering. Spacecraft could quickly scout out potentially dangerous areas or monitor unusual activities on distant planets, providing real-time data that is crucial for making informed decisions. This kind of agility could mean the difference between thwarting an attack and being caught off guard. Furthermore, FTL travel could facilitate collaboration among different spacefaring nations or organizations, allowing for a united front against common threats. By enabling fast troop movements and the sharing of resources, FTL technology could foster alliances based on mutual defense agreements. Moreover, the implementation of faster-than-light travel might allow for the establishment of advanced early warning systems, alerting us to incoming threats from light years away. If we could detect hostile forces at a great distance, FTL travel would enable us to react almost instantaneously, giving us the upper hand in any confrontation. The strategic possibilities are immense, as fleets could be positioned at various points throughout the galaxy, ready to respond quickly to any sign of aggression. This level of preparedness could deter potential aggressors, knowing that any hostile action would be met with an immediate and overwhelming response. However, the introduction of FTL travel into space defense would also raise important questions about regulation and control. Who would have access to this technology, and how would it be governed? The potential for misuse or escalation of conflict could become a pressing concern, as nations or groups with FTL capabilities might engage in aggressive posturing. This could lead to a new kind of arms race in space, where speed and technology become the primary factors in determining military strength. In conclusion, while the concept of faster-than-light travel remains theoretical for now, its implications for space defense strategies are profound, potentially transforming how we protect our interests in the cosmos and redefining the balance of power in an ever-expanding universe. As we delve into the intriguing realm of space exploration, the prospect of faster-than-light FTL travel opens up a universe of possibilities that could significantly alter international treaties governing space activities. Currently, space treaties like the Outer Space Treaty of 1967 outline principles for the peaceful use of outer space, emphasizing that space shall be free for exploration and use by all countries, and that celestial bodies cannot be claimed by any nation. However, if humanity were to develop FTL technology, the dynamics of space exploration would change dramatically, necessitating a reevaluation and potential revision of these treaties. With the ability to travel faster than light, nations could reach other star systems in a matter of days or weeks, rather than the decades or centuries that current technology would require. This newfound speed raises questions about territorial claims in space. Would countries attempt to stake claims on planets or moons in distant solar systems, leading to conflicts reminiscent of historical territorial disputes on Earth? The need for clear guidelines on ownership and exploitation of extraterrestrial resources would become more pressing. Moreover, the prospect of FTL travel could attract private companies and entities into the mix, complicating the international legal landscape. The involvement of non-state actors could challenge existing treaties, which primarily focus on nation-states. As companies venture into space exploration with FTL capabilities, regulations would need to evolve to ensure that their activities align with international laws and prevent potential exploitation of celestial resources. Additionally, the speed of travel would facilitate more frequent encounters between different nations in space. This could lead to the establishment of new protocols for communication and cooperation in space missions, fostering collaboration among countries that share the goal of exploring the cosmos. Treaties may need to incorporate guidelines on how nations interact with each other in space, especially in terms of scientific research and exploration, ensuring that these activities are conducted peacefully and cooperatively. The potential for FTL travel also raises concerns about the environmental impacts of space exploration. As we venture further into the universe, it is crucial to consider the effects of our actions on celestial bodies and their ecosystems. International treaties would likely need to address the preservation of these environments, similar to how we protect endangered species and habitats on Earth. In conclusion, the introduction of faster-than-light capabilities into space exploration would transform the landscape of international treaties, prompting a comprehensive reassessment of existing agreements. The need for new regulations that address ownership, interaction, environmental concerns, and the role of private entities in space would be paramount, shaping the future. Imagine a world where scientists could reach distant galaxies in mere moments. The implications for scientific research would be astounding, transforming our understanding of the universe and accelerating discoveries at an unprecedented pace. With such rapid travel, researchers could study celestial bodies up close, collecting samples from planets, moons, and asteroids that are currently light years away. This would not only expand our knowledge of the composition and history of these celestial objects, but also provide insight into the potential for life beyond Earth. Furthermore, the ability to explore distant galaxies would open new avenues in astrophysics, allowing scientists to test theories in real time. They could observe cosmic phenomena like supernovae, black holes, and neutron stars from a vantage point that was previously impossible. This direct observation would lead to a deeper understanding of the fundamental laws of physics, potentially leading to breakthroughs that could redefine our understanding of space and time. With quick access to different celestial environments, researchers could also study the effects of various gravitational fields on biological organisms. This could inform us about how life might adapt or evolve in alien ecosystems, offering clues about the possibilities of life on other planets. For instance, examining how terrestrial life responds to the conditions of a close exoplanet could provide valuable insights into the resilience and adaptability of organisms. Moreover, the implications for collaboration between scientists across the globe would be significant. Teams could work together in real time, sharing findings and experiences as they explore new worlds. This could foster a new era of international scientific cooperation, uniting minds from different cultures, backgrounds, and disciplines to tackle the mysteries of the universe. Imagine the potential for technology transfer as well. The innovations and tools developed for space travel could be adapted for Earth, leading to advancements in materials science, energy production, and environmental monitoring. The knowledge gained from studying other planetary systems might also provide solutions to some of our pressing challenges here at home, such as climate change or resource scarcity. In addition to all these scientific advancements, the cultural and philosophical implications would be profound. Humanity's perspective on its place in the universe would shift dramatically. As we discover new worlds and possibly intelligent life forms, questions about our existence, ethics, and responsibilities towards other beings would arise. This could lead to a new understanding of what it means to be human in a vast and interconnected cosmos. In essence, the ability to reach distant galaxies in moments would not only revolutionize scientific research, but would also reshape our society, technology, and understanding of life itself. The quest to explore the universe. Faster than light travel, while still a concept rooted in science fiction, could revolutionize our understanding of cosmic events, such as supernovae, by allowing scientists to observe these dramatic phenomena from much closer distances and in real time. Normally, when a star explodes in a supernova, the light and radiation it emits take years or even centuries to reach Earth. This delay means that the data we gather about these explosive events is often limited and can only provide a snapshot of what happened long ago. However, if we could travel faster than light, astronomers could reach these stellar explosions almost immediately after they occur, enabling them to capture the event as it unfolds. This real-time observation would mean that researchers could study the initial phases of the explosion, gaining insights into the mechanics of the blast, the materials ejected into space, and the conditions under which these stars explode. Additionally, being able to travel faster than light would allow scientists to visit various locations in the universe to collect samples and perform experiments on the remnants of supernovae, potentially uncovering new elements or compounds created during the explosion. The implications of this enhanced understanding could extend beyond just supernovae. It would also deepen our knowledge of the life cycle of stars, the formation of black holes, and the dynamics of galaxies. Furthermore, faster-than-light travel could facilitate collaboration among scientists across the galaxy, as researchers could easily share findings and work together on experiments in ways currently unimaginable. This could lead to rapid advancements in astrophysics and cosmology, as insights gathered from one supernova could be swiftly compared with observations from another, leading to a more comprehensive understanding of stellar evolution and the forces governing the universe. If scientists could witness supernovae in real time, they would also be able to study the effects of these explosions on surrounding celestial bodies, including their impact on nearby star systems and the potential for creating new stars from the materials expelled during an explosion. This could reshape our understanding of stellar nurseries and the environments that foster the birth of new stars. Moreover, the ability to travel faster than light might also enable the exploration of other cosmic events, such as gamma-ray bursts and neutron star collisions, providing a broader context for understanding the universe's most energetic phenomena. Ultimately, faster-than-light travel could transform our approach to studying the cosmos, turning long-held theories into observable science and making the mysteries of the universe more accessible than ever before. While we are still far from achieving this technological marvel, the idea. When we talk about traveling faster than light, we often dive into the realm of science fiction, but it's intriguing to consider the potential risks of encountering unknown phenomena in such a scenario. The universe is full of mysteries, and pushing the boundaries of speed could lead to unexpected encounters with strange cosmic entities or anomalies. For example, if you were to travel at such incredible speeds, you might find yourself in regions of space where the laws of physics behave differently. This could mean running into areas with intense gravitational fields that could warp space-time around your spacecraft, creating unpredictable and possibly dangerous situations. Moreover, the cosmic environment is teeming with various forms of matter and energy, some of which we might not even be able to detect with our current technology. Imagine zooming through a cloud of dark matter or dark energy, which remains largely a mystery to scientists. Such encounters could have unpredictable effects on your ship's systems, or even on the fabric of reality itself. Additionally, as you approach or exceed the speed of light, you might experience time dilation, where time moves differently for you compared to those on Earth. This could lead to disorienting experiences, making it difficult to gauge how long you've been traveling or even if you've aged. Another risk could stem from colliding with particles in space. At light speed, even the tiniest speck of dust could cause catastrophic damage due to the sheer amount of energy involved in such a collision. The vacuum of space is not as empty as it seems, and the potential for hidden hazards is vast. Furthermore, traveling faster than light might open doors to other dimensions or parallel universes, each with its own set of rules and dangers. If you were to accidentally slip into one of these alternate realities, you could encounter entirely foreign life forms or environments that you're unprepared for, leading to perilous situations. It's also worth considering the psychological impacts of such a journey. The vastness of space can be isolating, and racing through the cosmos at incredible speeds could heighten feelings of loneliness and fear of the unknown. The mental strain of facing unpredictable phenomena could lead to anxiety or even affect decision-making, which is critical in emergencies. In essence, the thrill of exploring the universe at faster-than-light speeds is matched by the potential dangers lurking in the unknown, reminding us that while the cosmos is a place of wonder, it is also filled with risks that we have yet to fully understand. The discovery of faster-than-light travel could fundamentally alter our understanding of the Big Bang in several fascinating ways. First, let's consider the nature of the universe itself. Currently, the Big Bang theory explains how the universe expanded from an extremely hot and dense state around 13.8 billion years ago. This expansion occurred at a speed that was limited by the speed of light, meaning that no information or matter could travel faster than this cosmic speed limit. If faster-than-light travel were possible, it would suggest that there are mechanisms or forces in the universe that we do not yet understand, potentially opening up new avenues of physics. With this new capability, we might be able to observe regions of the universe that are currently beyond our reach. Light from these distant areas has not had enough time to reach us since the Big Bang, so we are left with a limited view of the early universe. Faster-than-light travel could allow scientists to explore these regions and gather more data about the conditions that existed shortly after the Big Bang. This could lead to new insights about the formation of galaxies, stars, and even the fundamental forces of nature that shaped our universe. Moreover, if we could travel faster than light, we might also be able to send probes or even human explorers back in time, theoretically allowing us to witness the events of the Big Bang itself. While time travel comes with its own set of paradoxes and challenges, the ability to observe the universe as it was at its inception could provide direct evidence for or against various models of cosmic evolution. This could help us refine our theories or even develop entirely new frameworks that better explain the nature of reality. Additionally, the implications for communication would be profound. Currently, sending signals across vast cosmic distances can take millions or even billions of years due to the speed of light limitation. If we could communicate faster than light, we could share discoveries and information across the universe in real time. This would not only enhance our understanding of cosmic events, but could also lead to collaborations with potential extraterrestrial civilizations, fundamentally changing our place in the universe and our understanding of life beyond Earth. In conclusion, the discovery of faster-than-light travel holds the potential to reshape our comprehension of the Big Bang, revealing new mysteries about the origin of the universe and possibly leading to groundbreaking advancements in our understanding of physics, time, and space. Faster-than-light travel has long been a topic of fascination in science fiction, but scientists are exploring various theoretical concepts that could one day make it a reality. One idea involves the use of warp drives, which would manipulate space around a spacecraft rather than moving the craft itself faster than light. This concept suggests that by contracting space in front of the ship and expanding it behind, a vessel could effectively travel faster than light without violating the laws of physics as we understand them. To power such a warp drive, researchers speculate about harnessing forms of energy like negative energy or exotic matter, which are still hypothetical but could exist under certain conditions. Another intriguing possibility comes from the concept of wormholes, shortcuts through spacetime. If we could create or stabilize a wormhole, it might allow for instant travel between two distant points in the universe. The energy required to create a stable wormhole is currently beyond our capabilities, but in theory, harnessing quantum fluctuations or tapping into the energy of black holes might provide the necessary power. Additionally, there is the idea of using antimatter as a fuel source. Antimatter is the counterpart to regular matter, and when the two meet, they annihilate each other, releasing tremendous amounts of energy. If we could find a way to produce and store antimatter safely, it could potentially serve as a powerful energy source for spacecraft, enabling faster travel across vast distances. Moreover, recent studies in quantum mechanics have hinted at the possibility of manipulating particles at an incredibly small scale. This might lead to new technologies that could one day allow for faster-than-light communication, which, while not the same as travel, could revolutionize how we connect across the cosmos. Lastly, there are theories surrounding zero-point energy, the energy present in empty space due to quantum fluctuations. If this energy can be harnessed, it could provide a nearly limitless power source, opening doors to advanced propulsion systems that could push the boundaries of our current understanding of physics. Each of these ideas represents a fascinating avenue of research, sparking the imagination and inspiring scientists and dreamers alike to explore the final frontier of space travel. Faster-than-light travel is a concept that has fascinated scientists and dreamers alike, presenting intriguing possibilities for cosmology, the study of the universe. If such travel were possible, it could revolutionize our understanding of the cosmos in numerous ways. For starters, it would allow us to explore distant galaxies and stars that are currently beyond our reach, enabling us to gather data from places we can only observe through telescopes. Imagine being able to visit other star systems in a matter of days or weeks, rather than the thousands of years it would take with current technology. This could lead to groundbreaking discoveries about the formation and evolution of galaxies, as well as the potential for extraterrestrial life. Additionally, faster-than-light travel might help us test theories about the universe's structure and expansion. For instance, we could directly observe cosmic phenomena, such as supernovae and black holes, and gather evidence that could confirm or challenge existing theories about dark matter and dark energy. The ability to communicate with distant civilizations or even other forms of intelligent life could also reshape our understanding of life in the universe, leading to new insights into biology, evolution, and the conditions necessary for life. Moreover, faster-than-light travel could allow for a better understanding of the Big Bang and the early universe. By traveling to the edges of the observable universe, scientists could collect information about the conditions that existed shortly after the Big Bang, revealing the nature of cosmic inflation and the fundamental forces that shaped the universe. Such insights could redefine our theories of physics and bring us closer to a unified understanding of the forces governing the cosmos. However, the implications of faster-than-light travel also raise significant questions. For instance, time dilation and the effects of traveling at such speeds could challenge our concepts of time and space, leading to paradoxes that could complicate our theories. Furthermore, the ethical considerations of interacting with other civilizations or ecosystems must be taken into account. The potential risks and benefits of such travel would need to be carefully weighed, ensuring that exploration does not come at the expense of other worlds or their inhabitants. In essence, faster-than-light travel could open up a frontier of knowledge that is currently unimaginable, pushing the boundaries of what we know about the universe and our place within it. The quest for understanding the cosmos would take on a new dimension, inspiring future generations to explore, discover, and comprehend the wonders that lie beyond our own planet. Dark matter and dark energy are two of the most mysterious components of the universe, and understanding them could have profound implications for our grasp of physics, cosmology, and even the nature of reality itself. For instance, dark matter, which makes up about 27% of the universe, is believed to be the invisible glue that holds galaxies together. Its existence is inferred from the gravitational effects it has on visible matter, radiation, and the large-scale structure of the universe. If scientists can pinpoint the properties of dark matter more accurately, it could lead to breakthroughs in particle physics, potentially discovering new particles or forces that we have yet to understand. On the other hand, dark energy accounts for about 68% of the universe and is thought to be responsible for the accelerated expansion of the universe. Its nature remains largely unknown, and unraveling its mysteries could change our understanding of gravity and space-time. If dark energy is a cosmological constant, it suggests a steady energy density filling space homogeneously, while alternative theories propose dynamic forms of energy that could evolve over time. The implications of discovering the true nature of dark energy could lead to new insights into the fate of the universe, whether it will continue to expand forever, slow down, or even reverse into a big crunch. Moreover, the interaction between dark matter and dark energy could redefine our understanding of the cosmos. For example, if dark matter influences the behavior of dark energy, scientists might need to revise current models of the universe's expansion. This could also mean that our theories about the formation and evolution of galaxies, stars, and planetary systems might be incomplete or even incorrect. The quest to understand these phenomena is not just a matter of academic curiosity. It could illuminate the very fabric of the universe, leading to a deeper understanding of fundamental forces and the overall structure of space and time. In addition to the physical implications, understanding dark matter and dark energy could have philosophical consequences as well. If these components are found to be different from our current models, it could challenge our perceptions of reality and how we fit into the universe. Are there other dimensions, alternate realities, or forms of matter and energy that we have yet to discover? Such questions push the boundaries of human knowledge and challenge our understanding of existence itself. Furthermore, advancements in technology and observational techniques, such as more powerful telescopes and sophisticated simulations, are paving the way for discoveries that could clarify these enigmatic elements. Each new finding adds a piece to the puzzle, enhancing our comprehension of. Imagine a world where different civilizations could interact at superluminal speeds, allowing cultures to exchange ideas, traditions, and knowledge almost instantaneously. In such a scenario, the way we understand and appreciate wildlife and animals would transform drastically. Picture a group of scientists from one civilization traveling to another galaxy in mere moments, sharing their discoveries about unique animal species they encountered. They could bring back fascinating information, such as the behaviors of luminescent creatures that thrive in the dark oceans of distant planets, or share tales of massive intelligent beings that communicate through intricate sound patterns. As these civilizations interact, they would likely engage in collaborative efforts to study and protect endangered species across various worlds. Imagine a team comprised of biologists from Earth, explorers from a water-based planet, and researchers from a forested moon working together on projects that benefit wildlife everywhere. They might use their advanced technologies to monitor animal populations, track migration patterns, and even develop techniques to restore habitats damaged by environmental changes. Cultural exchanges at such high speeds would also lead to the blending of artistic expressions inspired by wildlife. Artists from different civilizations could share their interpretations of animals through music, dance, and visual arts, creating a rich tapestry of creativity that reflects the diversity of life across the universe. These shared experiences would foster a deeper appreciation for nature and the intricate relationships that exist within ecosystems. Language would evolve too, as various civilizations incorporate terms and concepts related to wildlife into their communication. New words could emerge to describe animals that do not exist in a particular culture, leading to more nuanced discussions about conservation and the importance of biodiversity. This exchange of knowledge would not only enhance scientific understanding, but also promote empathy and respect for all living beings, regardless of their origin. Additionally, educational systems might adapt to include a broader curriculum that encompasses the wildlife of many worlds. Students would learn about the ecological challenges faced by different species across galaxies and how they can contribute to solutions that transcend their own planet. This interconnectedness could give rise to a new generation of eco-conscious citizens who view themselves as stewards of the universe's diverse wildlife, advocating for protection and preservation efforts that span multiple civilizations. Overall, if civilizations could interact at superluminal speeds, the exchange of knowledge and culture would lead to a profound transformation in our understanding of animals and wildlife. The potential for collaborative conservation efforts, innovative artistic expressions, and a shared commitment to protecting the natural world would create a vibrant, interconnected community that celebrates the wonders of life in all its forms. In exploring the fascinating concept of faster-than-light travel and its potential impact on education systems, it's essential to think about how this groundbreaking technology could reshape the way we teach and learn about the universe. Imagine a classroom where students are not just learning about the stars and planets, but are also preparing for the possibility of traveling to distant galaxies in the blink of an eye. Educators could incorporate real-time data from interstellar journeys, allowing students to participate in live discussions with astronauts or researchers stationed on other planets. The curriculum might shift to include subjects like astrobiology and cosmic navigation, providing learners with the tools needed to understand life on other worlds and the science behind traversing vast distances. With faster-than-light travel, the concept of distance would change dramatically, which means geography lessons would adapt accordingly. Instead of focusing solely on Earth's continents and countries, students could explore the geography of other planets and moons, learning about their atmospheres, climates, and potential for life. Virtual reality could play a significant role in these lessons, allowing students to experience the surface of Mars or the rings of Saturn as if they were there, providing a more immersive learning experience. Moreover, the idea of time could also be re-examined. If traveling faster than light allows for journeys that could bend our understanding of time, then history lessons would need to expand beyond Earth's timeline, potentially including the histories of alien civilizations and their technologies. This could spark students' imaginations, encouraging them to think critically about the implications of meeting other intelligent life forms and how these interactions might influence human culture and society. In this new educational landscape, collaboration could become key. Schools might partner with space agencies and research institutions to provide students with hands-on experiences, such as internships that involve real projects related to space travel and exploration. This collaborative approach would not only enhance learning but also prepare students for careers in a rapidly changing job market where space exploration plays a crucial role. Furthermore, ethical discussions would likely become an integral part of the curriculum, as students would need to consider the moral implications of interstellar travel, including the responsibility of humans to other worlds and life forms. This aspect would encourage students to engage in debates about colonization, environmental impact, and the preservation of extraterrestrial ecosystems, giving them a sense of responsibility as future explorers. As technology evolves, so too would the tools available for education. Online platforms could connect students from different parts of the universe, allowing them to share knowledge and experiences, breaking down barriers that once seemed. The exploration of faster-than-light (FTL) travel technologies is a fascinating topic that intersects with science fiction and theoretical physics, but it also raises important questions about governance, safety, and ethical considerations. In a world where FTL travel becomes a reality, the role of government would be multifaceted and crucial. First and foremost, regulations would need to be established to ensure the safety of both travelers and any potential environments they might encounter. Governments would likely be responsible for setting safety standards for FTL spacecraft, determining what kind of materials and technologies are acceptable for use, and ensuring that these vehicles are rigorously tested before they are allowed to operate. Moreover, governments would have to consider the environmental impact of FTL travel. Just as we currently grapple with the effects of air travel on our planet, similar concerns would arise with FTL travel, including the potential for space debris and the unknown consequences of traveling faster than light. Regulations would need to address these issues, promoting sustainable practices and minimizing harm to both space and Earth environments. Another significant aspect of government involvement would be the establishment of legal frameworks for interstellar travel. As we venture beyond our solar system, questions of jurisdiction and ownership would come to the forefront. Governments might need to negotiate treaties regarding the use of space resources, the rights of individuals and organizations to explore or settle on new planets, and the responsibilities of travelers towards any extraterrestrial life they might encounter. In addition to safety and legal concerns, ethical considerations would play a critical role in how governments manage FTL technologies. The potential for FTL travel could lead to unequal access to these technologies, creating a divide between those who can afford to travel the stars and those who cannot. Governments would need to address these inequalities to ensure that the benefits of FTL travel are shared fairly among all people. Furthermore, the potential for FTL travel could lead to new forms of conflict as nations and corporations vie for control over new territories and resources. Governments would need to develop policies to prevent such conflicts and to promote peaceful exploration and cooperation among nations. This could involve international agreements and bodies that oversee FTL travel, much like how international air travel is managed today. In conclusion, the role of government in regulating faster-than-light travel technologies would encompass a wide range of responsibilities, from ensuring safety and environmental protection to addressing legal, ethical, and geopolitical challenges. As we continue to explore the possibilities of FTL travel, it is essential to consider how governance can shape a future where faster-than-light travel is a concept that has fascinated scientists, writers, and dreamers alike for many years. Imagine the possibilities if we could travel faster than the speed of light. It would not only change our understanding of physics, but also open up new avenues for exploring the universe. For instance, current scientific theories, such as Einstein's theory of relativity, are built on the premise that nothing can surpass the speed of light. If we found a way to exceed this limit, it would challenge and potentially reshape our understanding of space and time. New theories could emerge to explain the mechanics behind such travel, possibly introducing concepts that blend quantum mechanics with general relativity, leading to breakthroughs in our comprehension of the fabric of the universe. Additionally, faster-than-light travel could lend credence to ideas like wormholes and warp drives, which have been largely theoretical until now. If scientists were able to observe or even create such phenomena, it would push the boundaries of modern physics and inspire new mathematical frameworks to describe these extraordinary capabilities. As we explore these ideas, we could see a surge in interdisciplinary studies, combining physics, engineering, and even philosophy, as we ponder the implications of traveling across galaxies in mere moments. Moreover, the potential for interstellar travel could ignite a new era of exploration, prompting scientists to rethink the possibilities of life beyond Earth. If we could reach distant star systems, it would lead to the development of new technologies and theories about the existence of extraterrestrial life, the formation of planets, and the conditions necessary for life to thrive. This shift in perspective would encourage researchers to formulate hypotheses about the universe's structure and the fundamental laws that govern it. The influence of faster-than-light travel could extend beyond theoretical physics, impacting our understanding of communication and information transfer. Imagine being able to send messages across vast distances almost instantaneously. This capability would not only revolutionize how we communicate, but also challenge the very notions of causality and simultaneity. Scientists would need to grapple with the implications of transmitting information faster than light, leading to debates and new theories on the nature of time itself. In the realm of technology, achieving faster-than-light travel would likely trigger an explosion of innovation. Engineers and scientists would need to collaborate to invent new materials, energy sources, and propulsion systems capable of withstanding the challenges of such extreme speeds. This collaborative spirit could lead to technological advancements that benefit other fields, such as medicine, renewable energy, and environmental science. Furthermore, the cultural and philosophical ramifications of the possibility of faster-than-light travel has captured the imagination of many, and while we often think about the scientific and technological implications, it also raises questions about potential conflicts or competition among nations. If humanity were to unlock the secret of traveling faster than light, it could change the dynamics of global power in profound ways. Nations might scramble to develop their own faster-than-light technologies, leading to an arms race reminiscent of the space race of the 20th century. Imagine countries racing to establish colonies on distant planets or mining asteroids for resources, which could lead to disputes over territory and ownership. As nations vie for dominance in this new frontier, alliances may shift and old rivalries might resurface, creating a landscape where cooperation becomes as crucial as competition. This new era of exploration could also lead to conflicts over the ethical implications of colonizing other worlds. Questions about the rights of potential extraterrestrial life forms, if they exist, would arise. Furthermore, nations might harness faster-than-light travel for military purposes, deploying fleets across the galaxy much like navies patrol the oceans today. The potential for conflict could escalate quickly, with nations feeling threatened by each other's capabilities or intentions. The fear of being left behind could drive governments to take drastic measures, leading to preemptive strikes or cyber warfare targeting each other's technology. The race for resources could also spark competition as nations seek to exploit new worlds for their minerals, water, and energy sources, potentially leading to conflicts similar to those seen during the age of colonial expansion on Earth. Moreover, the advent of faster-than-light travel might exacerbate existing geopolitical tensions. Countries that are currently rivals could see the opportunity to gain strategic advantages over one another, while those that are more cooperative might find themselves at odds with nations that prefer a more aggressive approach. As humanity reaches out to the stars, the potential for misunderstandings and miscalculations increases as communication across vast distances becomes a challenge. The risk of unintended conflicts could grow, especially if nations are unable to establish clear protocols for engagement or exploration in space. Additionally, the prospect of encountering other intelligent life forms could add a new layer of complexity to international relations. How would nations react if they were to discover advanced civilizations? Would they engage in diplomacy, or would the instinct to dominate take precedence? The presence of alien species could lead to a new form of competition, not only between nations on Earth, but also between humanity and these extraterrestrial beings. The ethical dilemmas surrounding first contact, resource sharing. Imagine a world where we could travel faster than light, a concept that currently exists only in the realm of science fiction. If this were possible, the very idea of distance as we understand it would undergo a profound transformation. Right now, when we think of distance, we consider it in terms of time and space. For example, when we say that a star is 1,000,000 light-years away, it means that the light from that star, traveling at its maximum speed, takes 1,000,000 years to reach us. However, if we could move faster than light, these vast distances would feel entirely different. Instead of waiting for light to travel across the universe, we could potentially traverse these enormous gaps in mere moments. This means that the universe might seem much smaller, as we would be able to visit distant stars and galaxies in a fraction of the time it currently takes. The concept of space would shift from a seemingly infinite expanse to a more connected and accessible environment. Imagine looking up at the night sky and knowing that with just a quick journey, you could explore the surface of a distant planet or witness the beauty of a nebula up close. Furthermore, the implications for communication would be equally astounding. Currently, when we send a message to a spacecraft billions of miles away, we have to wait for the signal to travel at the speed of light. If we could communicate faster than light, we could share information instantaneously across vast distances, changing the way we interact with information and each other. In this scenario, the barriers of distance might dissolve, allowing for a new era of exploration and knowledge sharing that we can only dream of today. Additionally, our understanding of time could also be redefined. The relationship between distance and time is a fundamental aspect of physics, but if we could travel faster than light, we might experience time differently. The notion of how we perceive time while traveling vast distances could lead to fascinating discussions about the nature of reality itself. Would we still measure time in the same way, Or would our experiences create a new understanding of time as something more flexible? In this hypothetical world, the very laws of physics would be challenged, leading to new theories and possibilities. Scientists and thinkers would likely spend years unraveling the mysteries of this new form of travel, exploring its consequences and how it fits within our existing understanding of the universe. Ultimately, if distance could be altered by the ability to travel faster than light, it would not only change how we perceive our place. Exploring the concept of parallel universes through faster-than-light travel opens up a fascinating world of ethical dilemmas that touch on our understanding of life, existence, and responsibility. Imagine a scenario where explorers can step into alternate realities, each with its own set of rules, histories, and beings. One major ethical concern is the potential for interference in these parallel worlds. For instance, if a traveler were to alter a significant event in a different universe, it could lead to unforeseen consequences, not only for that world but possibly for our own as well. The butterfly effect, where small changes can lead to large differences, becomes a critical consideration when dealing with the fabric of existence itself. Additionally, the issue of consent arises. If explorers encounter sentient beings in these alternate realities, they must consider whether these beings have the right to remain undisturbed. Is it ethical to observe or interact with a society that is unaware of the existence of other universes? The line between exploration and exploitation can blur quickly, leading to moral quandaries about the rights of these beings. Furthermore, if travelers can bring back resources, knowledge, or even technology from these parallel worlds, questions about fairness and equity emerge. Would this create a new form of colonialism, where one universe benefits at the expense of another, raising debates on the morality of such actions? Another dilemma involves the implications of encountering versions of ourselves in these universes. How would we react to seeing different outcomes of our own lives? This could lead to deep psychological impacts, as we may face regret, envy, or even a desire to change our own reality based on what we observe. The existential questions about identity and self-worth could become overwhelming as we grapple with the idea that there are countless versions of ourselves living out different fates. Moreover, the potential for conflict in alternate realities cannot be overlooked. If different versions of humanity exist, what happens when they collide? The prospect of meeting a more advanced civilization raises questions about power dynamics and the potential for conflict or cooperation. Would we be seen as equals, or would one universe attempt to dominate another? This leads to a broader ethical concern about our responsibilities as travelers and the impact of our actions on the interconnected web of realities. Ultimately, while the idea of exploring parallel universes is thrilling, it brings forth a myriad of ethical dilemmas that challenge our understanding of morality, responsibility, and the consequences of our actions across multiple realities. As we delve into these uncharted territories, we must imagine a future where humans have unlocked the secrets of faster-than-light travel, allowing us to traverse the vast expanses of the galaxy in mere moments. This incredible advancement could revolutionize humanitarian efforts, enabling aid to reach those in need across countless worlds. For instance, consider a distant planet facing a devastating natural disaster, like a massive storm or an earthquake. With traditional travel methods, it could take weeks or even months for assistance to arrive. However, with faster-than-light technology, emergency supplies, medical teams, and rescue missions could be dispatched instantly, saving lives and alleviating suffering in real time. Furthermore, imagine how this capability could facilitate the establishment of sustainable colonies on other planets. By quickly sending experts in agriculture, medicine, and engineering, we could help these new settlements thrive, ensuring that they have access to the resources and knowledge necessary for a healthy and prosperous community. This swift response could also foster collaboration between different worlds, as nations and organizations work together to address challenges that transcend planetary boundaries, sharing technology and expertise to solve common problems. Additionally, faster-than-light travel could enable the transport of vital resources from one planet to another, addressing shortages that could lead to crises. For instance, if a planet is running low on fresh water or food, assistance could be sent without delay, ensuring that the population remains safe and healthy. This capability could make it possible for us to establish a network of support across the galaxy, where help is always just a moment away, regardless of distance. Moreover, the ability to travel faster than light could also enhance our understanding of different cultures and ecosystems, allowing volunteers and researchers to engage directly with communities that may be struggling. This direct interaction could lead to more effective solutions tailored to the unique needs of each planet's inhabitants. By sharing knowledge about sustainable practices, healthcare, and education, we could empower these communities to build resilience against future challenges. In the realm of wildlife conservation, faster-than-light travel could provide an unprecedented opportunity to protect endangered species across different planets. Imagine conservationists being able to reach remote habitats quickly, ensuring that both flora and fauna are safeguarded from threats such as poaching, habitat destruction, or climate change. This could lead to innovative programs designed to educate local populations about the importance of biodiversity, fostering a sense of stewardship for their natural environments. Ultimately, the potential for faster-than-light travel to facilitate humanitarian efforts across the galaxy is immense. It could lead to a new era of compassion and connectivity, where help knows no bounds. In a universe where faster-than-light travel becomes a reality, humanity's identity could undergo profound changes that expand not only our understanding of ourselves, but also our place in the cosmos. With the ability to traverse vast distances in mere moments, the concept of community might shift dramatically. Instead of being tied to specific geographical locations on Earth, people could form connections with others scattered across different planets, stars, or even galaxies. This interstellar connectivity could lead to a more diverse cultural exchange, blending traditions, languages, and ideas from various worlds, enriching the human experience in ways we can only begin to imagine. As we explore new planets, our sense of identity might also become more planetary or even cosmic. No longer just Earthlings, people might start identifying as citizens of the universe, fostering a sense of belonging that transcends single planets. This broader perspective could lead to a greater emphasis on cooperation and collaboration among different civilizations as we learn to navigate the complexities of interstellar relationships. It may spark a newfound appreciation for the uniqueness of each world, urging humanity to become more environmentally conscious and responsible stewards of our own planet while considering the ecosystems of others. Moreover, the technological advancements necessary for faster-than-light travel could lead to significant shifts in our social structures. The pursuit of knowledge and exploration might become central to our identity, fueling a new age of discovery akin to the great eras of exploration on Earth. The sciences and arts could flourish, driven by the inspiration drawn from the myriad of life forms and environments we encounter. With the capacity to witness and interact with alien species, we might also reevaluate our understanding of life and intelligence, challenging preconceived notions about what it means to be sentient. In this exciting new reality, our relationships with technology could deepen as well. As we rely on advanced spacecraft and AI to navigate the stars, humanity's identity may intertwine with our creations more than ever before. This could lead to questions about what it means to be human in an age where machines play such a significant role in our exploration and existence. The blending of biological and technological aspects might even inspire new definitions of identity, as we consider the potential for enhanced humans or hybrid beings existing alongside traditional humanity. Additionally, the ethical considerations surrounding contact with extraterrestrial life may reshape our moral frameworks. As we encounter other intelligent beings, we will face critical questions about rights, respect, and coexistence. These challenges could prompt us to develop a more inclusive identity, one that values empathy and understanding across species and civilizations. Did you know that elephants have an incredible memory? They can remember places, other elephants, and even humans for many years. This memory is crucial for their survival, as it helps them navigate their vast habitats and find water sources during dry seasons. Interestingly, elephants communicate using low-frequency sounds that can travel long distances, allowing them to stay in touch with other herds. This ability to communicate is not just limited to vocal sounds, they also use body language and even infrasound to convey messages. Another fascinating aspect of wildlife is the way certain animals form partnerships to enhance their survival. For example, oxpeckers, small birds often seen riding on the backs of large mammals like rhinos and buffalo, play a crucial role in their ecosystem. These birds feed on ticks and other parasites that infest their hosts, providing a cleaning service in exchange for protection and a place to find food. This relationship benefits both species, showcasing the beautiful interdependence found in nature. Shifting to the ocean, did you know that dolphins have complex social structures? They live in groups called pods, which can consist of just a few individuals or up to 100. These pods are often made up of family members or close friends, and they engage in cooperative hunting, where they work together to catch fish. Dolphins are known for their intelligence and playful behavior, often seen leaping out of the water or riding the waves created by boats. Their ability to communicate using a series of clicks and whistles adds to their social interaction, making them one of the most intriguing marine animals. In the forests, the relationship between trees and fungi is equally captivating. Trees provide carbohydrates to fungi, while fungi help trees absorb water and nutrients from the soil through their extensive networks. This partnership, known as mycorrhiza, is essential for the health of many ecosystems. In some cases, trees can even share nutrients with other plants through these fungal networks, demonstrating the interconnectedness of life in the forest. Meanwhile, in the world of reptiles, chameleons are famous for their ability to change color. This remarkable skill is not just for camouflage, it also plays a crucial role in communication and temperature regulation. When a chameleon is excited or agitated, it may display bright colors to signal its mood to other chameleons. Additionally, by changing their colors, they can absorb more sunlight when they are cold or reflect light to cool down when it's hot, showcasing their adaptability to various environments. As we explore further,